good evening to all of you. Okay, so today we are going to start the subject mass transfer operation. तो आज का लेक्चर बहुत ही इम्पोर्टेंट है और why it is important because today I will try to cover all the basic parts of the mass transfer operation. Okay, so the subject is mass transfer operation. Mass transfer operation. Now, before starting the subject, I would like to ask कि what do you know about the mass transfer? What do you know about the mass transfer? As the name suggests, first of all, it is very important to clear some doubts about the mass transfer that we are going to start here, because as the name suggests, the mass transfer means if any fluid is going to flow from through the pipe, it is also the mass is going to transfer. You can also say mass transfer is there. Okay, because some mass of the fluid element is going to transfer from the one point to other point. It is also the mass transfer. Now, if any object we are going to transport from one point to other point, it can be also called as a mass transfer. But whatever the mass transfer we are going to start here, we are going to discuss here, that is not the mass transfer like flow of fluid in the pipe. ये mass transfer की बात मैं नहीं कर रहा हूँ. I am not talking about this types of mass transfer. Here the mass transfer I am talking about if the transfer of the material or transfer of the molecules are taking part due to difference in concentration. Okay. So although here also the mass is transferring from one point to other point as the fluid going to flow through the pipe or fluid flow over the flat plate, mass is transferring, but जो mass transfer की मैं बात कर रहा हूँ, whatever the mass transfer I am talking here, that is not this. Okay, this one is not the mass transfer I am talking about. The subject here. तो mass transfer that we are talking about, तो जो mass transfer की मैं बात कर रहा हूँ, whatever the mass transfer I am talking about, the transfer of the molecules from the region of higher concentration to lower concentration, or you can say the transfer of the mass which are taking place because of difference in concentration. Okay, a concentration gradient, that is called as mass transfer. Now, just similar to the heat transfer, in the heat transfer it is transfer of energy or transfer of heat because of difference in temperature. Now, as the heat, how can define the heat transfer? I told you the heat transfer can be defined as energy in transit because of difference in temperature. Okay, if energy is going to transfer because of temperature difference, that is called as heat transfer. Similarly, I can define the mass transfer as the it is a mass in transit because of concentration gradient. Okay, so that mass transfer I am talking about here. Is this clear? Yes or no? So you should not confuse about the mass transfer through this. It is actually bulk flow, not the mass transfer. So although it is other thing कि whenever the any molecules are going to transfer from the one point to other point due to higher concentration from the region of high concentration to low concentration, there may be also a bulk flow. Bulk flow will also be associated with the concentration difference. Means what I am talking about, just try to understand here. कि if any molecules or any atoms are going to transfer, molecules basically, if any molecules are going to transfer from the region of higher concentration to lower concentration, along with that, okay, means that is the transfer of the species because of concentration difference. But along with that transport of the species because of concentration difference, there is also associated bulk flow. Am I right? Yes or no? There is always associated bulk flow. It is not possible to have a pure transfer of a species because of concentration difference. Pure, although it is not always possible, you can say. It is not always possible to have a pure transfer of a species from the region of high concentration to lower concentration, even because of concentration difference. It is not always, once again listen, it is not always possible to have a pure transfer of a species because of concentration gradient. Whenever there is a concentration gradient, there is also maybe possibility of associated bulk flow. I will give you example. Clear? Yes or no? So what is the mass transfer actually? That we should know. When any system you have, and when the system consists of more than one components, when a system is there and system consists of more than one components. When you have a system and system consists of more than one components and their concentration of the components vary from the point to point. If their concentration of the components vary from the point to point, then there is a natural tendency. There is a natural tendency to equalize the concentration. Yes or no? To uniform the concentration. It is a natural process. Just like a heat transfer is a natural. Why? Because if anywhere the difference in temperature is there, there is a heat transfer is there. Then if you have a system having more than one components, and if there is a difference in concentration, then the molecules of the particular component will transfer from the region of high to low concentration. Clear? So that is the actually mass transfer I'm talking about. And actually this natural tendency is just to equalize the concentration. Is this clear? Yes or no? And the transport of the components or constituent species from the region of high concentration to low concentration in order to minimize the difference in concentration or equalize the concentration difference, that is called as mass transfer. Is this clear? So please you can write if you want the basic definition. Is this everything is correct? Yes or no? Everything is fine? So I think you should not write the definition. If anyone asks you, mass transfer means transfer of species from the region of high concentration to low concentration is called as mass transfer. Okay? Or you can say if a system consists of more than one species, if your system consists of more than one species, then there is a natural tendency of the mass to be transferred in order to minimize the difference in concentration. And the transport of the species from the region of high concentration to low concentration in order to equalize the in order to become uniform concentration throughout is called as mass transfer. Clear? So I think there is no need of writing this statement. कोई ज़रूरत है क्या? बोलो. तो हम इम्पोर्टेंट चीज़ों को ही फिगर आउट करेंगे. भाई अगर लिखना है तो सिंपल मैंने बोल दिया कई बार, आप लिख सकते हो. If a system consists of more than one species having difference in concentration, then there is a natural tendency for the mass to be transferred in order to minimize the concentration difference, and that transport of a species from the region of high to low concentration is called as mass transfer. Okay. Now there are various practical examples or industry example as well as daily life or common examples are there which we face throughout the day. For example, as far as common daily life examples are there, in the morning whenever you wake up, just you are having a tea, है ना? You are just waking from the bed just with the bed tea, है ना? So in what you are going to do, if you want to make the tea, you should dissolve the sugar cube, है ना? So if you want to dissolve the sugar cube in the hot water, so this is the mass transfer operation, because sugar cube is a solid and it has to be diffused within the liquid, है ना? So this is your mass transfer operation, because solid has to be diffused within the liquid. Okay, and that diffusion is because of solubility, because that sugar cube have solubility in the liquid. If suppose if you are going to drop the stone will not able to dissolve. Why? Because stone has not solubility in the liquid. Is this clear? So this is again the mass transfer operation. Second is that if you are going to dry the cloths under the sun, okay, when you are going to expose the wet cloth under the sun in order to dry the cloth, what happen? There is again mass transfer operation is there, because the moistures in the wet cloth has to be removed out. This is again the mass transfer operation is there. Okay, if you are going to burn the agarbatti, है ना, for worship, suppose पूजा करने के लिए आप, if you are going to burn the agarbatti in the one corner of the room, then due to difference in concentration of molecules of agarbatti, because the corner of the room where you have burned the agarbatti have high concentration of molecules of agarbatti as compared to other corner, then due to difference in concentration, the fragrance molecules or you can say molecules of agarbatti will diffuse from the region of one corner where you have burned to the other corner. That is only because of difference in concentration, because I told you there is a natural tendency for the molecules in order to equalize the concentration or minimize the difference in concentration at least. Is this clear? Now, so there are various examples are there. Kajal, any problem? Now perfumes, suppose if you are going to spray the perfume, then you might have seen if you are going to spray the perfume in this room, then its fragrance can be spread in the other room as well because of difference in concentration. So that is all an example of common life example of the mass transfer operation. Now as far as industrial example of the mass transfer operation is there are various example of the industrial application of the mass transfer. For example, dispersion of the gases from the stacks. Stacks means just like chimney. So there are various industries are there, and in every industry there are stacks are there, and through stacks the various gases has to be move out. So gases are going to be diffused from the stacks to the atmosphere. This is only because of diffusion. Why diffusion? Because here the concentration is high and atmosphere the concentration is low. What concentration I'm talking about? Concentration of the gases which are going to release out. So in order to minimize the concentration, the gaseous molecules which are releasing from the stacks has to be diffused. This is again the mass transfer operation is there. This is industry example of the mass transfer operation. Now other industry example of mass transfer is the stripping of the gas from the wastewater. Suppose you have a wastewater, and if you want to remove some certain impurities in the wastewater, called as stripping, then you have to contact the wastewater with the gaseous stream called as solvent, and that gas must have ability to absorb the solute that has to be transferred from the solvent, called as liquid wastewater. So if you want to purify the wastewater, so in the wastewater, suppose if you want to remove the concentration of fluorine or chlorine, then in that process what you should do in the stripping operation, the liquid which is wastewater has to be contact with the gaseous phase, called as solvent. Feed phase is the wastewater and the solvent phase is the gas. So as the gas and feed phase, solvent phase and feed phase is allowed to be in the contact, there is a mass transfer operation is there, and since whatever solvent we have fed, that must have solubility for that particular chlorine or fluorine, otherwise no mass transfer is there, otherwise less mass transfer is there. So if the solvent that you are going to place that have high solubility for the particular solute which has to be transferred, then the fluorine or chlorine has to be dissolved in the water, and that's why in this way we can reduce the concentration of the fluorine or chlorine in the wastewater. That is another example called stripping. Is this clear? That is stripping. Clear hai? Yes or no? And if anyone have done the training in the ammonia plant, there is a two tower is there, absorption tower and stripping tower. In a stripping tower we are using the steam as solvent in order to absorb the diethanolamine which get absorbed in the liquid in the absorption tower. Similarly, suppose as per the government other example is absorption. Another example is absorption. In absorption, what happens? The transfer of the solute is from the gas phase to liquid phase. Now in the stripping we have reduced the concentration of the solute from the liquid phase by supplying the solvent phase which is gas phase. In the absorption, what happens? In the feed phase is the gas phase and solvent phase is the liquid phase, and if you want to remove the concentration of the solute that present in the gas phase to a permissible limit, then you have to contact that gas phase with the solvent liquid phase. For example, if you want to reduce the concentration of carbon dioxide from the flue gases, as I told you in the process calculation, you might have solved the various problems. When the hydrocarbons are going to burn, then the unreacted methane, for example, unreacted hydrocarbon like methane is there, and the formed like CO, CO2, O2, N2, H2O, all are releasing out. So whatever flue gases are there, if you want to reduce, because as per the norms by the Central Government Pollution Act, you are not allowed to dispose the any concentration of the pollutants directly to the atmosphere. Some limits has been set up by the Pollution Control Board, and you have to follow that norms. So in order to follow that norms, you have to reduce the concentration of the CO2 or any pollutants from the flue gases to the permissible limit, and that is only possible if you are going to pass that flue gas through the liquid solvent. Liquid solvent. The liquid solvent must have ability to absorb that pollutants, otherwise not possible to have a mass transfer. Vishal, I will discuss each and everything, just please wait. तो अगर आप चाहते हो कि मास ट्रांसफ़र हो तो जो सॉल्वेंट आप ऐड कर रहे हो उसके पास सॉल्युबिलिटी होनी चाहिए उस सॉल्यूट के लिए, ठीक है ना। तो ये भी एक मास ट्रांसफ़र ऑपरेशन है। तो मैंने बोला बहुत सारे ऐसे एग्जांपल्स हैं, फॉर एग्जांपल एब्जॉर्प्शन, स्ट्रिपिंग, इन डिस्टिलेशन इफ यू वांट टू separate the two liquid mixture like A and B, you have a binary liquid mixture, and if you want to separate the pure A and pure B, then you have to carry out the mass transfer operation like distillation. Now another is extraction. So there are various industrial mass transfer operations are there, and various applications are there. We will see also in the upcoming section. Clear है? तो common example we have seen, and industrial example we have also discussed, and these mass transfer operations are very, very important. Now as I have given you the industrial example of the mass transfer, in the industrial example of the mass transfer at least two phases must be required for the mass to be, along with the feed phase. If you have feed phase is single solution phase, if your feed is a single solution phase, then you have to supply, either you have to supply another phase or you have to create the another phase. Are you getting my point? The two types of, I can also classify the mass transfer in the two ways, like some mass transfer operation must require the supply of the second phase called a solvent phase, another is has to be create the second phase. So for every industrial mass transfer operation, Mr. Vishal, for every industrial mass transfer operation, Mr. Vishal, Ritik Verma Vishal, for every mass transfer operation, industrial mass transfer operation, at least two phases should be required. So one phase is called as feed phase and other is called as solvent phase. Okay, that second phase, apart from the feed phase is different thing. If you have a feed phase, then another phase must be required, and that two phase should be allowed in the contact. And when the two phase, feed phase and solvent phase, is allowed to be in the contact, then there is a mass transfer operation taking place, and how these are going to take place we'll discuss in the upcoming section. But for every industrial mass transfer operation, at least two phase should be required. One is feed phase and other is called as solvent phase. Now that second phase, you can say second phase can either be supplied or can be created. For example, in the absorption, in the stripping, in the extraction, we are supplying the second phase as a solvent. Clear? While in distillation, we are creating the second phase by supplying the energy. Is this clear? सब कुछ दिमाग में बैठा लो. Clear है या नहीं है? In distillation operation, we are not going to supply any second phase. Okay? In distillation operation, simple liquid phase is there. We are going to create the second phase. We are going to generate the second phase by supplying the energy. Okay? Now, in absorption, in stripping, in extraction, in leaching, all other mass transfer operations require the supplying phase. So either the second phase, either we can supply or we can create. Is this clear? Now the next thing is that what is driving force for the mass transfer? What is driving force for the mass transfer? Actually, in a single phase, if I'm talking about single phase mass transfer operation, now which are not industrial obviously, so in single phase mass transfer operation, for example, if you are going to spray the perfume, if you are going to burn the agarbatti, like that, then obviously the fragrance of the all molecules are going to transfer from the one region to the other region of lower concentration. So that is actually because of concentration difference. So you can say for a single phase, if I am talking about the mass transfer operation in only single phase, then in single phase the driving force is, in single phase the driving force for the mass transfer is concentration difference. But if I am talking about the multiple phases or more than one phases, for example, listen, try to understand. So here I am going to write driving force for the mass transfer in single phase. In single phase, driving force is concentration difference. Or chemical potential. Chemical potential is common, I will discuss later on. So in single phase, the driving force is the concentration difference that I can say. But if I am talking about the multiple phases as a whole, for more than one phases, for any mass transfer operation which involve more than one phases, more than one phases. For example, absorption, stripping, extraction, etc. True driving force is chemical potential, or chemical potential is driving force. Chemical potential is driving force. Okay, chemical potential is the driving force, and that I will discuss in the thermodynamics. Okay, what is the chemical potential? Listen, why chemical potential? First write this point, then I will discuss. In single phase, driving force is concentration difference. For more than one phases, for example, absorption, stripping, extraction, distillation, etc., the chemical potential is driving force. Okay. Now it means, if we are, what is meaning of have you written this? Yes or no? Yeah, chemical potential. So actually, as a whole, we should say the chemical potential is true driving force. Concentration difference is not the true driving force. The reason is that because, for example, if suppose you have a two phases, for example, it is gas phase and here liquid phase. The two phase is allowed to in the contact, and this is called interface, where the two phase is allowed in the contact. The contact is called as interface. Interface, clear? They are interface. Where the two phases are allowed in the contact is called as interface. They are gas phase and they are liquid phase. तो जहाँ पे ये दोनों contact में आ गए, they are called as interface. Now listen here. If I'm talking about individual gas phase, then here driving force is only concentration difference. Am I right? From the bulk of the gas to the interface, it is single phase, na? This region is single gas phase. This is a single liquid phase. It is single gas phase and it is single liquid phase. So if I'm talking about individual gas phase, individual liquid phase, they are single phase. So in individual gas phase, the driving force is the concentration difference. And also the concentration difference is there in the liquid phase. But if I'm talking about as a whole, means mass is transfer. When the gas and liquid phase is allowed to be in the contact, there is a continuous mass transfer is taking place from the gas to liquid and liquid to gas as well. Okay, but net mass transfer is from the either left to right or right to left, depending upon the solubility of the components in the gas or in the liquid. Clear hai? Bolo. When the two phase is allowed to be in the contact, and it is better to understand like that. Suppose this you can do yourself. Simple. You have a tank and this is filled with the liquid water, H2O, and this is allowed to be in the contact with ammonia in the gas phase. Ammonia is there, half filled with the water and half filled with the ammonia. Clear? Half filled with the water and half filled with the ammonia. And where the two phase in the contact called interface, this is interface and this is closed container. Now in this case, when we are going to keep it for the sufficient time, what happens? Some molecules of the ammonia will get absorbed in the water, and some molecules from the water will also get transferred in the ammonia. But in general, ammonia is more soluble in the water, and if we are not going to bother about any evaporation operation, we are not going to consider evaporation, then what happens? The ammonia has some solubility in the air, in the water, sorry. Ammonia is soluble in the water. Then whatever the transfer, it means ammonia, some molecules of the ammonia will get transferred from the gas phase to liquid phase, and at the same time some ammonia will also get transferred from the liquid phase to gas phase. Are you getting a point? Yes or no? Bolo. When the ammonia and water is allowed to be in the contact, some molecules of the ammonia, because ammonia is soluble in the water, then some molecules from the ammonia molecules will get absorbed into the water. At the same time, some ammonia from the water also get transferred in the gas phase, from liquid phase to gas phase. तो जो अमोनिया है वो गैस से लिक्विड में जाएगा, लिक्विड से गैस में भी जाएगा कुछ, ठीक है ना. But net transfer of the ammonia is, the net transfer is there. The net transfer of ammonia from the gas to liquid. The net transfer I am talking about. Net transfer is from the gas to liquid. And that transfer of the mass of the ammonia, that net transfer of the mass of the ammonia from the gas to liquid is continuous until the both ammonia in the gas phase, means what, when both vapor phase and liquid phase will not reach to the equilibrium. There is a condition when there is no change, since ammonia will get absorbed in the water, then concentration of the ammonia in the water called as x and here y is the concentration, either mole fraction or mass fraction. The mole fraction of the ammonia, and x is the mole fraction of ammonia in the liquid phase, and y is the mole fraction of ammonia in the gas phase. So since initially the mole fraction of the ammonia in the liquid phase is 0 because water is pure, but as it is allowed to be in the contact, ammonia will get absorbed. So as ammonia start absorbs, then obviously the concentration of ammonia in the liquid phase called as x is going to be changed, increases, yes or no? And at a given temperature and pressure, if you are going to carry out this operation at a given temperature and pressure, then there is a condition when the system will reach to the equilibrium. And what is the meaning of equilibrium? I told you, equilibrium means seized condition. Equilibrium means there is no any macroscopic change. There is no any macroscopic change, means the condition of equilibrium means nothing is going to happen, driving force is going to be 0. Okay, and once the equilibrium will get established, between the two phases, so at equilibrium driving force is always 0. Listen carefully, at the condition of equilibrium driving force is always 0 and the process is assumed to be ceased. Nothing is going to happen at the macroscopic level. At the macroscopic level nothing is going to be changed. Whatever is going to happen only at the microscopic level. But the net observable change which you can observe by the naked eyes, you won't find anything. Okay, it means now x and y is going to be constant. Either you can put for 2 days or 3 days, 4 days. If you are going to maintain same temperature and same pressure, then y and x will not change further. It means when these compositions are going to be constant, no further change in the composition of x and y, means concentration of ammonia in the gas phase and liquid phase, it means this is the indication of equilibrium has been established. Clear? Bolo. Clear है? Yes or no, Mr. Karthik? If you have any problem, you can ask me. एक कंडीशन ऐसी आएगी जहां पे x और y में कोई भी चेंज नहीं होगा अगर t और p फिक्स है तो, यानी ये जो कंडीशन है दैट इज इंडिकेशन ऑफ इक्विलिब्रियम हैज बीन एस्टैब्लिश्ड. देन द क्वेश्चन इज दैट इवन द y एंड x आर नॉट सेम, इवन y एंड x आर सेम, लेट्स से इवन इट मे बी पॉसिबल कि y and x are same in the value at any given set of temperature and pressure. If you are going to carry out this operation at different temperature and pressure or different composition of y and x, then it may be possible कि at some points, for example, this y and this x may be same, like here 0.5 and here 0.5. Okay, it may be possible, not always, but it may be possible कि y and x are same. Is this clear? Or it may be different even. Suppose it is 0.4, that is also possible, and it is most general. It is 0.4, it is 0.3. 0.4 and 0.3 means x and y, you can say this 0.4 and this 0.3. नहीं सर मिस्टर जय प्रजापति सर, यही तो बता रहा हूँ आपको सर. प्रजापति साहब सुन लीजिए, इफ y इक्वल टू 0.4 एंड x इक्वल टू 0.3, अगर ये कंडीशन हो गई तो फिर तो आपने सब कुछ आसान कर दिया, पूरा थर्मोडायनामिक्स खत्म हो गया. ठीक है सर, ये 0.4 और ये 0.3 मीन्स कंपोजिशन ऑफ अमोनिया in the vapor phase is 0.4 and composition of ammonia of liquid in liquid phase is 0.3. That these two are equilibrium composition. These are in equilibrium. It means, what does it mean there? If at the given set of temperature and pressure, simple meaning is that when at a given set of temperature and pressure, when the ammonia having composition 0.4, it is air plus ammonia actually, then only question air plus ammonia mixture is there. Air plus ammonia mixture is there. Now, when you have a air ammonia mixture having ammonia composition 0.4 and you have a liquid having ammonia composition is 0.3, when you are going to allow to be in the contact at a given set of temperature and pressure, what happen? Please tell me. अगर आपने इस टेम्परेचर और प्रेशर पे आपने अमोनिया एयर मिक्सचर लिया जिसमें अमोनिया का कंपोजिशन 40% है, और आपने एक लिक्विड कंपोजिशन लिया, लिक्विड मिक्सचर लिया जिसमें अमोनिया का कंपोजिशन 30% है, और अगर आपने इन दोनों को कांटेक्ट में किया तो क्या मास ट्रांसफर होगा? इज इट पॉसिबल टू हैव एनी मास ट्रांसफर? Is it possible to have any mass transfer? There is no mass transfer. Why? Reason is that because these two conditions, these two composition of the ammonia in the vapor phase and liquid phase are in equilibrium. It means this composition will make the chemical potential of the ammonia in the vapor phase and liquid phase in equilibrium, or they are unequal. It means at this point 4, the chemical potential of ammonia in the vapor phase and the chemical potential of ammonia of this composition in the liquid phase will make this equal. Clear है? बोलो. So how in thermodynamics language, how can I define the two driving force? Because even the concentration difference is there. Here 0.4, here 0.3. Even the concentration difference is there, but there is no mass transfer is going to happen. It means the two driving force for the mass transfer is not the concentration difference. Am I right? In this case, even the composition of ammonia in the vapor phase and liquid phase is different. So I am talking about between the two phases, more than one phases. In single phase, again the driving force is concentration, you can say. Is this clear? But if I am talking about as a whole, among the two phases, the two driving force cannot be said as a concentration difference, because here in this example, even the 0.4, here 0.3, their difference in the concentration is there, but still there is no mass transfer. It means the two driving force is not the concentration difference, means something should be different. Okay, and that is called as chemical potential. What is chemical potential? I will discuss. Chemical potential will vary with the temperature, pressure and composition. As the composition will change, chemical potential will change. Now it means in thermodynamics I will discuss कि this is mu is a function of temperature, pressure and composition of vapor and liquid phase, x and y. So at a given temperature and pressure, if you are going to change the composition of either vapor or liquid, what happened? The mu will change here. As the mu will change, then there is again driving force for the mass transfer called as chemical potential difference. Am I right? Yes or no? Clear hai? It means if you want to know the two driving force among the phases, then the chemical potential or chemical potential gradient is the true driving force for the mass to be transferred. Is this clear? In single phases, if you have a single phase, for example only gas phase is there, in single phase that difference in the concentration from one point to other point will make the chemical potential different. Here mu1 in the same phase, mu1 in the, let's say, gas phase and mu2 in the gas phase. This mu1 and mu2 are not same. This mu1 in the gas phase is not equal to mu2 in the gas phase, because concentration in the gas phase is not equal to concentration at the 2 point in the gas phase. Is this clear? It means in single phase, listen, in single phase the difference in the chemical potential is because of difference in composition or concentration. Okay, but in multiple phases the difference in the chemical potential is not because of composition only. Clear? Here in single phase I told you, in single phase the difference in the chemical potential is because of difference in composition. If composition is same, then chemical potential is same, then no mass transfer is going to happen, because concentration difference is 0, then chemical potential difference will also be 0. But as far as multiple phases is concerned, in multiple phases the chemical potential is going to vary not because of only composition. It means even the composition is going to be same here. What I am saying, are you getting my point? Even the composition of the vapor and liquid phase is going to be same, but still chemical potential in the two phases is not going to be same. Chemical potential in two phases is not going to same even with the composition are same. Clear? The true driving force for the mass transfer is, then you can say as a whole, the true driving force for the mass transfer is chemical potential, not the concentration difference. Chemical potential difference in chemical potential instead of concentration difference. Okay, clear है? But अगर आपसे कोई पूछता है कि what driving force in for the mass transfer, then you can say ये सर concentration difference. तो आपको फायदा क्या होगा कि आपको एक क्वेश्चन बन जाएगा, बोलेगा मल्टीपल फेज में क्या होगा, तो आपको एक क्वेश्चन का आंसर देने को मौका मिल जाएगा. अगर आपने पहले ही बोल दिया कि सिंगल फेज में कंसंट्रेशन डिफरेंस है और मल्टीपल फेज में केमिकल पोटेंशियल है, तो फिर एक क्वेश्चन आपको कम हो गया. समझ गया? जो आपको आता था, समझे नहीं? तुम समझो हमें आता ही नहीं है, कोई पूछे तो बोलो कि क्या ड्राइविंग फोर्स, बोलो कंसंट्रेशन डिफरेंस सर, तो बोलेगा अच्छा कंसंट्रेशन डिफरेंस है, अब बताओ ये दोनों फेज आपस में यहाँ तो मास ट्रांसफर नहीं होगा, तब बोलो सोचो थोड़ा सा, बोलो सर केमिकल पोटेंशियल, समझे ना? तो तुम इंटरव्यू में थोड़ा सा प्लान करना पड़ता है, तुम खुद उसको चांस मत दो, अपना एक जो स्ट्रांग पॉइंट है ना उसको पूछने का मौका दो, समझे ना? तो इट इज क्लियर अबाउट ड्राइविंग फोर्स, यस और नो? प्लीज टेल मी, इट इज क्लियर अबाउट द ड्राइविंग फोर्स? तो ट्रू ड्राइविंग फोर्स फॉर द मास ट्रांसफर इज केमिकल पोटेंशियल डिफरेंस. केमिकल पोटेंशियल मत बोलना, केमिकल पोटेंशियल डिफरेंस और डिफरेंस इन केमिकल पोटेंशियल। एंड तो बोलेगा आपसे कि क्या सिंगल फेज में केमिकल पोटेंशियल डिफरेंस नहीं हो सकता है क्या? तो बोला सर होगा, उसमें भी होगा। उसमें क्या होगा सर? बोला कि सर इन सिंगल फेज द केमिकल पोटेंशियल डिफरेंस इज बिकॉज ऑफ अ केमिकल पोटेंशियल इन सिंगल फेज इज गोइंग टू वेरी विद द कंपोजिशन, है ना। बट इन मल्टीपल फेजेस केमिकल पोटेंशियल अगेन वेरी विद द कंपोजिशन बट डिफरेंटली। ऐसा नहीं कि सेम वेरी करेगा, डिफरेंटली वेरी करेगा। तो इवन द सेम कंपोजिशन इन द मल्टीपल फेजेस इन द वेपर एंड लिक्विड फेज स्टिल द केमिकल पोटेंशियल में बी डिफरेंट। ठीक है, समझ गया मिस्टर कार्तिक? एंड इन थर्मोडायनेमिक्स यू माइट हैव studied कि two phases are said to be in equilibrium at the given temperature and pressure when the chemical potential or fugacity of every species are equal. Are you getting the point? आपने पढ़ा होगा ना कि दो फेजेस, ये तो थ्योरी तो पढ़ाई होगा ना, बट उसका एप्लीकेशन बता दे रहा हूँ कि अगर दो अल्फा एंड बीटा, two different phases are there and these two phases are said to be in equilibrium at the given temperature and pressure. This is from thermodynamics. I will discuss in thermodynamics at a given temperature and pressure two phases are said to be in equilibrium, thermodynamic equilibrium, when the chemical potential or fugacity you can say mu I of every species in all phases must be equal. Mu I alpha must be equal to mu I beta at constant temperature and pressure. Similarly, or fugacity of a species fi cap in alpha phase equal to fi cap in beta phase. ये ध्यान रखो, मैं वहां पे याद दिलाऊंगा जब थर्मो स्टार्ट करूंगा। ओके, एट गिवन टेम्परेचर एंड प्रेशर फ्यूगोसिटी ऑफ एवरी स्पीसीज, नॉट ओनली अमोनिया अगर जो भी स्पीसीज होंगे उसका इन ईच फेजेस द फ्यूगोसिटी ऑफ ईच स्पीसीज और केमिकल पोटेंशियल ऑफ ईच स्पीसीज मस्ट बी सेम। ये तो कभी थ्योरी पढ़ा होगा ना, बोलो। तो दिस इज द क्राइटेरिया फॉर two phases to be in equilibrium, and when the two phases are in equilibrium then there is no mass transfer or heat transfer. Is this clear? Now what is similarity between the heat transfer and mass transfer? Similarity is that just like in the heat transfer the driving force is the concentration difference, temperature difference. Similarly in the mass transfer driving force is concentration difference if I am talking about single phases. Clear? But at the same time there is a difference, and difference is what? Try to understand here. At the interface there is no any discontinuity in the profile. That is very very important sir. देखो हर चीज को सुन लो, जो वो दिमाग में बैठ जाएगा सारी चीजें। इन हीट ट्रांसफर एट द इंटरफेस मीन्स suppose if I am talking about the combined mode of heat transfer, conduction and convection. It is a solid object and here fluid is there, है ना, solid and here fluid. Then suppose this is the conduction and there is a convection. Here conduction is there and here convection is there. So in profile there is no any discontinuity, means there is no jump is there, na. But if I am talking about mass transfer, in the mass transfer when you have two phases, here it is solid phase and here that was fluid phase. Now in the mass transfer if you have a two phase, just like here liquid phase and here you have a fluid phase, gas phase, let's say fluid, liquid phase and gas phase, and this is interface. Here interface is this one. At interface there is no discontinuity, but in the mass transfer there is discontinuity is there at the interface. How? Try to understand sir. आपने देखा होगा कभी ऐसा कुछ? This is, let's say, gas phase and this is liquid phase, let's say, and this is interface. Now here this is the driving force for the mass transfer in the gas phase. Solute A in the gas phase will diffuse from the bulk of the gas to the interface, है ना? Now here let's say it is called as कोई वैल्यू है, बट यहाँ पे क्या होगा ना, here let's say YA in the bulk of gas and here YAI. क्लियर है? यहाँ बच्चे क्या YAG और यहाँ क्या YAI. इज दिस विजिबल टू यू? नहीं विजिबल है, कोई बात नहीं. here let's say YAG and here YAI. Okay, now YAG and YAI are the composition, concentration of the species in the bulk of the gas to the interface. Just like here it is TA and here TI. Okay, now but in this case what happened? In this case, here as far as driving force in the liquid phase is concerned, this is XAI and here it is XAL. XAI and XAL is there. Is this clear? Bolo. But this YAG and XAI, there is a gap is there. There discontinuity. Here it has been discontinued. Profile has been discontinued as interface. Why? Because at this point YAI and XAI are the means composition of A in the gas phase at the interface and composition of A in the liquid phase at the interface. Both are different. YAI and XAI, they are the composition of the A in the gas phase and in the liquid phase at the interface only. They are different. But in the heat transfer, the temperature at the interface either in the solid or in the liquid or in the fluid, it is same. Yes or no? So there is discontinuity is there. And this discontinuity is there because they are in equilibrium. Now it means for in the heat transfer, listen, in the heat transfer the two phases are said to be in thermal equilibrium when their temperature is same. Clear? That is basic. Why this is going to happen, I am going to clear it. Now in the heat transfer हम generally क्या बोलते हैं कि two phases are in thermal equilibrium when the temperature of the two bodies are same. So at the interface now at the interface the solid phase and fluid phase are in thermal equilibrium because their temperature are same at the interface. But here in this case, in the mass transfer, for the two phases to be in equilibrium, the equality of concentration is not the guarantee. Am I right? Yes or no? What is the guarantee? Which should be equal? Please tell me. Bolo. In the mass transfer, the two phases, yeah, exactly. Okay, it means this value, it means YAI and XAI are in equilibrium. YAI and XAI are in equilibrium at the interface. They are actually YAI and XAI are what? They are equilibrium value of the A at the interface in the gas phase and liquid phase. At this YI and this XI, chemical potential of A in the gas phase and chemical potential of A in the liquid phase is going to be same. Yes or no? Bolo. They are equilibrium composition at the given set of temperature and pressure. It means at this YI and this XI, chemical potential of A in the gas phase is found to be chemical potential of A in the liquid phase. Means at the interface the mass transfer is taking place and they reach to the equilibrium condition. So there is a difference here. In heat transfer at the interface of the two phases there is no discontinuity in the temperature, but or there is no discontinuity in driving force. But in this case there is a discontinuity in the concentration at the interface. Clear hai? Bolo. Means their YI and these XI are in equilibrium values, but they are not equal always. It is not compulsory that they should be equal. They may be YI may be more than XI or XI may be more than YI. YI may be more than XI and vice versa. But anything may be equal. Any possibilities is there, that is depend upon the equilibrium value. Clear? And actually this is solubility. This equilibrium value, solubility is also the condition of equilibrium. है ना? Solubility क्या शो करता है कि at a given temperature and pressure the solubility of any substance in the liquid is, for example, salt. In the PC you might have studied the salt at a given temperature and pressure have that much solubility. Let's say 25 gram per liter of solution. What it means? It means at a given temperature and pressure you can only add 25 gram. Maximum 25 gram can be added. So this is actually solubility. It means when at the given temperature and pressure the water has been dissolved 25 gram, no further salt can be dissolved. Is this clear? That is the maximum concentration. So they are obtained from the equilibrium condition. Yes or no? Bolo. Yeah. Is this clear? So how I can find the yi and xi, that I will discuss. This is the part of next. So this is all about your driving force and difference in the heat transfer and mass transfer. There is always discontinuity is there at the interface in the concentration, but there is no discontinuity in the temperature at the interface of two object when I am talking about heat transfer. Is this clear? Bolo. तो वी डिस्कस अबाउट द ड्राइविंग फोर्स, वी डिस्कस अबाउट द डेफिनेशन ऑफ मास ट्रांसफर. हमने अभी तक जो डिस्कस किया, वट एवर वी डिस्कस सो फार, वी डिस्कस द डेफिनेशन ऑफ द मास ट्रांसफर एंड ड्राइविंग फोर्स फॉर द मास ट्रांसफर एंड इंडस्ट्रियल एंड कॉमन एग्जांपल ऑफ द मास ट्रांसफर. ओके, नाउ एट द सेम टाइम वी शुड डिस्कस द मैकेनिज्म ऑफ द मास ट्रांसफर. अभी तक लगा आपको कुछ आपने टफ पढ़ा है? बताओ, अभी तक ऐसा कुछ लगा कि आपने बहुत कुछ टफ पढ़ लिया है मास ट्रांसफर में? Now next is mechanism. Of mass transfer. तो मतलब मैं कोई नई चीज नहीं बताई, कुछ कॉन्सेप्ट क्लियर नहीं हुआ आपका? कहने का मतलब ये है, अभी ना पूरा हीट रिवाइज करवा दूंगा मैं, तुम देखो कैसे है. अभी आज का 4 घंटा जो है ना बहुत ही इंपॉर्टेंट है. अभी देखो, there are two mechanisms there for the mass to be transferred. One is called as molecular diffusion. Molecular diffusion, oh better is that we should say molecular diffusion, eddy diffusion. अभी ध्यान सुनना, जो बता रहा हूँ सुन लो. मॉलिक्यूलर डिफ्यूजन एंड एडी डिफ्यूजन. अच्छा, मॉलिक्यूलर डिफ्यूजन मीन्स जस्ट लाइक कंडक्शन. इट इज जस्ट लाइक कंडक्शन. ये कन्वेक्शन नहीं है, ध्यान रखना. मॉलिक्यूलर डिफ्यूजन मीन्स आई टोल्ड यू ना कि ट्रांसपोर्ट प्रॉपर्टीज, इफ एनी ट्रांसपोर्ट प्रॉपर्टीज इज गोइंग टू ट्रांसफर बिकॉज ऑफ मॉलिक्यूलर मीन्स इज कॉल्ड एज मॉलिक्यूलर फिनोमेना. फॉर एग्जांपल इन द हीट ट्रांसफर, द ट्रांसफर ऑफ एनर्जी ड्यू टू molecule transfer, that is called as Fourier's law of heat conduction. In the mass transfer, it is fixed law. In the fluid mechanics, the momentum transfer by the molecular phenomena is defined by Newton's law of viscosity. है कि नहीं? Yeah, obviously. yi xi, Mr. Karthik, if yi and xi are same, fortunately, because it is not possible. But suppose if there is a probability of 0.000001, then obviously there is no discontinuity, but we are not so lucky. So, and we don't want such lucky to be a such lucky person ki yi and xi, then we are not able to learn things. Now the mechanism is how the mass is going to transfer. Just like in the heat transfer, 3 mechanisms are there, now conduction, convection and radiation. Conduction heat transfer was just because of molecular phenomena. बोलो. Molecular diffusion mechanism is how the mass is transferring. How the mass is transferring. What are different mechanisms are there for the mass to be transferred, or modes of the mass to be transferred, you can say, or sometimes you can say types of mass transfer or modes of heat transfer, sometimes mechanism also. So first is called as molecular diffusion. So molecular diffusion means that if the mass is transferring, if mass is transferring, बोलो अभी तक कोई प्रॉब्लम तो नहीं हो रही यार? देखो, तो मॉलिक्यूलर डिफ्यूजन मीन्स व्हेन द मास इज ट्रांसफरिंग बिकॉज ऑफ रैंडम मोशन ऑफ द मॉलिक्यूल्स फ्रॉम द रीजन ऑफ हाई कंसंट्रेशन टू लो कंसंट्रेशन. बिकॉज ये तो कॉमन सेंस है कि मॉलिक्यूल्स एक रीजन से दूसरे रीजन में मूव करेंगे. मॉलिक्यूल्स आर मूविंग फ्रॉम, मॉलिक्यूल्स मीन्स इन द फ्लूइड आई एम टॉकिंग अबाउट. नाउ ऑल्दो सॉलिड का सॉलिड में भी डिफ्यूजन होता है, सॉलिड कैन ऑल्सो डिफ्यूज द सॉलिड, बट फॉर एग्जाम्पल आपने देखा होगा, अगर अभी आप क्वेश्चन पूछो क्या सॉलिड से डिफ्यूज होता है सॉलिड में, यस हो सकता है, मैं बताऊंगा बाद में. तो हियर आई एम टॉकिंग अबाउट सपोज द डिफ्यूजन ऑफ फ्लूइड इनटू द फ्लूइड मीन्स वन फ्लूइड फ्रॉम अदर फ्लूइड. तो as far as fluid is concerned, the fluid में क्या हो, molecules are moving randomly, am I right? Molecules are moving randomly, and due to random motion of the molecules, because if random motion is not there, then obviously molecules cannot be transferred, even the concentration is very high, difference is very high, am I right? So that is called as diffusion. Diffusion means velocity, diffusion means just transfer, and this is called a molecular, it means due to molecules level. So when the mass is transferring because of molecular motion of the molecules, and molecules are random, so due to random motion of the molecules, if the mass is transferring from a region of high concentration to low concentration, is called as molecular diffusion. Is this clear? And that random motion of the molecules is going to be possible only with thermal energy. If thermal energy is not there, then molecules will not be able to move. Am I right? Bolo. So by virtue of thermal energy, every molecules have thermal energy. Due to thermal energy, the molecules are going to move from one point to other point randomly. Without thermal energy, molecules are not able to move. So due to thermal energy of the molecules have a random motion. That is from the Candy theory of the gases. Candy theory says that molecules are random in the motion, and as the molecules are going to, as any mass is transferring, any molecules are transferring, any species are transferring from the region of high concentration to low concentration because of random motion of the molecules, is called as molecular diffusion. Clear? Bolo. Just like I have told you, momentum transfer, molecular momentum transfer, the two types of momentum transfer is there. One is called molecular, other called as convective or bulk. So as far as molecular momentum transfer is there, अच्छा याद करो मोमेंटम ट्रांसफर तीन टाइप का होता है एक्चुअली देखोगे तो, एक तो मॉलिक्यूलर मोमेंटम ट्रांसफर और एक क्या कन्वेक्टिव मींस ड्यू टू बल्क फ्लो है कि नहीं, एंड थर्ड वन इज कॉल्ड एज इडीज. व्हेन टर्बुलेंट फ्लो इज देयर देन इडीज विल आल्सो बी देयर, एंड ड्यू टू इडीज देयर इज अ माइक्रोस्कोपिक मूवमेंट इन द फ्लूइड. समझो बात को एंड ट्राई टू रिलेट विथ द थ्री टाइप्स ऑफ मोमेंटम ट्रांसफर वी हैव सीन. Initially we have seen only two types, that is called as molecular momentum transfer and convective or advective momentum transfer. For example, I told you, if you are allowed to, if you are walking from your own desire, that transfer of your own is called as molecular. But if you are transferring because of crowd, that is called as advective momentum transfer or convective momentum transfer. Am I right? Bolo. And in every flow over flat plate, or you can say vertical plate is there, we cancel out the net effect of convective or advective momentum flux. Why? Because velocity is found to be same in x direction. याद है? याद करो, ये प्लेट है और हमने एक ये फ्लूइड है, ये फ्लूइड फ्लो हो रहा है इसके ऊपर, ये प्लेट के ऊपर हमने यहाँ पे एलिमेंट लिया and we have assumed difference element. Here the momentum transfer is due to bulk advection, and this is by molecular diffusion. So this effect has been cancelled out because velocity is same in x direction. Then only momentum transfer is by molecular momentum transfer. Am I right? So momentum can be transferred, and that was only in the laminar flow. Am I right? That was discussion we did only in the laminar flow, not in turbulent flow. Yes or no? I am going to clear each and every concept and try to relate with. Now, what happened if this same flow is turbulent? When the same flow is turbulent, then whatever tau I have defined tau at y and tau plus dy, this tau, if formula will be same here, then only the value of tau is going to change. Yes or no? Only the value of tau is going to change, and tau will be tau total. This is called as tau laminar plus tau eddies. Yes or no? Due to eddies, and that momentum transfer due to eddies has been given by the Reynolds stress model, rho into u prime v prime, and u prime v prime we have calculated by the Prandtl mixing model. So if I am talking about in turbulent flow, as a whole total three mechanism is there for the momentum will be transfer. One is called as due to bulk flow. Yeah, one is called as due to bulk flow, called as advection. Second is called as molecular momentum flux, and third is called as eddy momentum flux. Is this clear? Any problem? Please tell me. Eddies are there due to eddies and due to turbulency. Similarly, if you recall about the heat transfer, याद होगा आपको, my dear student. If you recall about the heat transfer, in the heat transfer also, suppose you might have derived the formula, no? Convection equation for the flow in the pipe. In this case we have assumed a small differential element. याद होगा आपको, अगर आप ओपन कर लो हीट ट्रांसफर का नोट्स. In this case we have assumed there is a conduction in a radial direction. We have assumed the conduction heat transfer in the radial. We have assumed the fluid element. I am just writing the conduction equation, convection equation, total energy equation actually, in the heat transfer. If you recall, my dear student, if this is the fluid is going to flow and I have assumed differential element, आप रिलेट करो, सब कुछ अभी रिकॉल हो जाएगा और रिवाइज भी हो जाएगा. ये हमने फ्लूइड एलिमेंट एज्यूम किया है. क्या हो जा रहा है यार? या नाउ इट इज करेक्ट. दिस इज योर फ्लूइड एलिमेंट जो हमने, नाउ दिस इज हैविंग लेंथ dx and having thickness dr. Am I right? Yeah. In this case we have assumed the only advection in axial direction. There is no conduction. Bolo. Means we have assumed the conduction in, yeah, the conduction in radial. Conduction in radial. Advection in axial. Conduction, only conduction. Only conduction in the radial and only advection. Only advection in axial. Okay, and no heat transfer in the direction of theta. याद करो. तो ये अब अच्छा, how can I write the equation? It is very simple, sir. No need to derive. I have told you ना कि derive करने जरूरत नहीं है. Just try to understand the physical significance. Now, if I am talking about conduction in the radial direction, that is simply cylinder coordinate is there. It is 1 by. Please tell me. It is found to be what? It is k. Oh, yeah. It is found to be 1 by r, k, r, del t by del r. 1 by r, 1 by r, del by del r, k into r, del t by del r. This term indicate you what? Net heat transfer by conduction in radial direction. Am I right? बोलो. या याद करो. अभी देखो मैं कैसे करूँगा relate. This is net heat transfer by conduction. Net heat transfer by conduction in axial direction. Am I right? Yeah. That is found to be equal to what? Net heat transfer by advection. And when advection is there, this will be what? Rho Cp into U into del T upon del X. And now if K is constant, then we will get alpha by R, del by del R, R del T by del R is equal to U into del T upon del X. This indicates you net energy transfer by advection. This indicates you net energy transfer by conduction. Is this clear? You can open the notes and you can check it. And if this U is given to you as a laminar flow, now if the flow is laminar, fully developed, then what is U at any given point? This would be U max into 1 minus R upon R का whole square. है कि नहीं? And ये क्वेश्चन में गेट में पूछा भी गया है कि नहीं? बोलो. How many of you are able to recall? सर सब कुछ रिकॉल करा दूंगा, ध्यान सुनो. Now, and मैंने बोला था, I have given you homework, मुझे अभी भी याद है कि what happen if I'm talking about the conduction in axial direction as well. I have given you homework how the total equation can be changed if I'm talking about the conduction in axial direction as well. When the conduction in axial direction is there, then in axial direction the cross section area is same. That is just like a slab. Right? So here one more term will be added here. Net heat transfer by conduction. This should be what? Anyone? Del T upon del X will be added. Na? Some terms like del T upon del X. क्या ऐड होना चाहिए? Please tell me. Yeah, very good. यहाँ पे d2t upon dx square. This will be added. Yes. यूनिट वर्सेस बैलेंस यार, अगर आपको लगता है कि होना चाहिए तो यूनिट से चेक कर लो. यूनिट बहुत ही इंपॉर्टेंट है. या दिस इंडिकेटिव नेट हीट ट्रांसफर इन द एक्सियल डायरेक्शन, है ना. तो नाउ इफ यू थिंक दिस इज ओनली फॉर लेमिनार फ्लो, तो व्हाट आर डिफरेंट मोड ऑफ हीट ट्रांसफर? वन इज बाय एडवेक्शन, one is by conduction. As a whole, what are different modes of heat transfer? Only you will find two. One is called as conduction, other is called as advection. Am I right? बोलो. अल्फा मल्टीप्लाई कर लो, कोई दिक्कत नहीं. अल्फा ठीक है, जो भी हो आप चेक कर लेना. हो ये तो यूनिट से आप चेक कर सकते हो, दैट इसमें कोई बड़ी बात नहीं है. तो नाउ व्हाट माय क्वेश्चन इज दैट व्हाट आर डिफरेंट टू मोड्स ऑफ हीट ट्रांसफर इज देयर. One is called conduction, other is called advection. Am I right? Now, similarly, in the previous example of momentum transfer, you have seen only two. You have seen only two. One is called as Newton's law of viscosity by molecular momentum flux, and advection, advective flux. Is this clear? मैं जो बताना चाह रहा हूँ उसको समझो. Now, अगर यही flow turbulent होगा, then what happen? If the same flow is turbulent, the only thing will change here, the Q total I should write here, this should be Q by laminar plus Q by eddies. Eddies role will also be there, है ना? बोलो. So again, as a whole, there is a total 3 mode of heat transfer. Now 3 mechanism, not mode you can say, mode तो 3 ही होगा, conduction के रेडिएशन, but mechanism जो होगा heat transfer के इसमें एक तो conduction हो गया. In this case, in this example, in this particular example, no radiation is there, then I'm not bothering about. So where is convection? I've told you now, when the conduction is going to assist by the bulk motion, called as convection, and that whenever and it is just a rule has been formed कि whenever any heat transfer, any mass transfer, any momentum transfer, or not momentum transfer, any heat transfer, momentum you can say, any heat transfer, any mass transfer, any momentum transfer is taking place in presence of fluid motion. In presence of fluid motion, this should represent in terms of coefficients like heat transfer coefficient in the heat transfer, in the mass transfer coefficient in case of mass transfer, and friction coefficient in the case of momentum transfer. Is this clear? The rule is there, simple rule. So although here bulk motion is there, it means this is the heat transfer along with the bulk motion, or motion. Whenever any transport property is taking place in presence of motion, that should be represented in terms of convective heat transfer coefficient. Similarly, if any mass transfer is taking place in presence of motion, fluid motion, that should be defined, their rate of mass transfer should be defined in terms of a coefficient called as mass transfer coefficient. Clear? And since when eddies are there, I told you now, you have seen either in momentum transfer or in the heat transfer, whatever subject you have covered, we derived analytical solution, exact analytical solution we only got for the laminar flow. But when turbulent flow is there, we should be very relaxed. This is the problem for those who are researching on that. But as a student, we should be relaxed. Why? Because we have to not go for any analytical solution that is already given as an empirical equation in terms of coefficients, heat transfer coefficient, mass transfer coefficient, and friction coefficient whenever turbulent flow is there. Now, one more thing, in this case we have neglected any bulk flow in the radial direction. Am I right? Bolo. In this formula, Harsha, please tell me, we have ignored the bulk, any heat transfer by bulk flow in the radial. Am I right? Yes or no? देख के बताओ. Mr. Karthik, are you getting a point? No, I think your thinking ability has to be fast, because already you are in the position to understand more and more than whatever I am delivering it here. Okay, this is just for simplification, otherwise mode is there, na? Yes or no? This is for simplification. We have cancelled कि any bulk transport of the energy in the radial, but this could be a mechanism of the energy transfer. Yes or no? This could be a mechanism for energy transfer. Possible hai? Yeah. So now listen, whenever the fluid is stagnant or in laminar flow, the only two mechanisms is there for the heat to be transferred in this example. One is called as, when the stagnant is there, listen, when the fluid is stagnant, then only one is there, called as conduction only. When fluid is stagnant. But when the laminar flow is there, then two. One is called bulk flow mechanism and second is called as conduction mechanism. And when the bulk flow and conduction is going to combine, to represent the heat transfer in terms of coefficient called as heat transfer coefficient. Clear है? Called as convection, convective heat transfer coefficient. उसको नाम देते हैं convection, उसको नाम दीजिए, मैंने convection दे दिया. Clear? Because I told you any transport processes which are taking place in presence of fluid flow, that should be always represent in terms of their rate of transport properties should be defined in terms of coefficients. Okay, no. So now as far as mechanism of the mass transfer is concerned, I told you first is called as molecular diffusion. So clear हो गया? What is molecular diffusion? Molecular diffusion means, and when the flow is laminar, always the molecular diffusion is taking place. It is always present. And when the flow is stagnant, if I am talking about mass transfer, now I am come to the mass transfer. Whenever mass transfer I am talking about, so when the mass transfer is taking place in the stagnant fluid or in the laminar flow medium, always the molecular diffusion is there. Yes or no? Always the molecular diffusion is there. Why molecular diffusion is there? Because of thermal energy of molecules. By the virtue of thermal energy molecules, there is random motion in the molecule is there, and there is a microscopic movement of molecules. So this molecular diffusion is what? It is random motion of the molecules at the microscopic level. At the microscopic level, not at the macroscopic level. Random motion of the molecules at the microscopic level will cause the mass to be transferred. This is one. So when the flow is laminar or when the flow is stagnant, the molecular diffusion is there. Okay, now next is called ADD. This is all about molecular diffusion, and molecular diffusion is very, very slow. Am I right? Why it is slow? Molecular diffusion is very, very slow. Why slow? Because you know from the kinetic theory of the gases, there is Brownian motion is there. Means suppose this molecule is have some energy, it is going to transfer, because this transfer is of energy and mass only because of collision. So when it is going to collide with other molecules, they will change its direction and speed. Then again collide with other molecules, then again it will change its direction and speed. The net movement in the particular direction is going to be decreased. For example, suppose, yes, due to collision, suppose I just want to move from one point to other point. Because of I have energy, but if I am going to move in the bulk in the crowd, then obviously I am not able to move the net distance that I have traveled in given time in particular direction is much small than the actual movement, because actually we move here, then we go for the some spaces, then again like in especially in the fair, in the crowds, we have to go here and there. And then if we are going to strike with other molecules, then we have to change the path. अगर पापा मिल गए तो फिर पूरा ही चेंज हो जाएगा, है ना? तो इस तरीके से जो नेट मूवमेंट होगा, द नेट मूवमेंट ट्रेवल बाय द मॉलिक्यूल्स इन ए गिवन डायरेक्शन इज वेरी स्मॉल देन द एक्चुअल मूवमेंट. एक्चुअल तुमने खूब घूम किया, इधर इधर उधर घूमा, लेकिन जो नेट मूवमेंट है, इट मीन्स इट विल वेरी वेरी स्मॉल देन द एक्चुअल मूवमेंट. ओके, तो दैट्स व्हाई इट इज वेरी वेरी स्लो प्रोसेस. Molecular diffusion is very, very slow process. Clear? Now come to the AD diffusion. So please write some points about the molecular diffusion. Write some points about molecular diffusion. Molecular diffusion is because of molecular diffusion by random and spontaneous microscopic movement. Random and spontaneous. Molecular diffusion is by random and स्पॉन्टेनियस, खुद से मूवमेंट होगा, क्योंकि ये तो स्पॉन्टेनियस मूवमेंट होता है मॉलिक्यूल्स का. मॉलिक्यूलर डिफ्यूजन इज बाय रैंडम एंड स्पॉन्टेनियस माइक्रोस्कोपिक मूवमेंट. माइक्रोस्कोपिक मींस एट मॉलिक्यूलर लेवल. बल्क में कुछ दिखाई नहीं देगा कि मूवमेंट हो रहा है ना. फॉर एग्जांपल, अगर सपोज बल्क में नहीं दिखाई देगा, मतलब क्या है कि सपोज आपने यहाँ पे एक बीकर है, दिस फिल विद वाटर, एंड इफ यू आर गोइंग टू ड्रॉप द इंक, ब्लू इंक, व्हाट हैपन, दिस इंक विल स्प्रेड in order to uniform the concentration. It will take sufficient time to make uniformity of concentration because it is molecular diffusion. And why it is a microscopic movement? Because you will not see any movement of the molecules at the naked eyes. At the microscopic level, it seems that it is stagnant. Yes or no? जैसे इंक ड्रॉप करोगे, इंक हर जगह डिफ्यूज हो जाएगा ना, और it will take sufficient time to make equalize the concentration throughout. It is very slow process. So that's why I told you molecular diffusion is by random and spontaneous, random and spontaneous microscopic movement of molecules as a result of, बोलो समझ में आ रहा नहीं आ रहा? आपको बाहर से कोई लगेगा ये तो फ्लूइड रुका हुआ है ना, फ्लूइड तो मूव नहीं कर रहा है, कोई बल्क मोशन तो है नहीं इसमें, तो जो भी मोशन है दैट इज ओनली बाय मॉलिक्यूल, बिकॉज मॉलिक्यूल्स आर गोइंग टू बी मूव एंड नेट मूवमेंट इज फ्रॉम द रीजन ऑफ हाई टू लो कंसंट्रेशन. तो लिसन, तो मॉलिक्यूलर डिफ्यूजन is by random and microscopic movement of molecules as a result of thermal motion or thermal energy, because the molecules are moving only because of thermal energy na. If the molecules are at absolute zero temperature, they will get freeze, no motion is there. It means they are only going to move because of thermal energy, as a result of thermal energy or thermal motion. So one is called molecular diffusion, which is because of random and microscopic movement of the molecules, random and microscopic movement of the molecules because of thermal energy or thermal motion. And if this motion is taking place from the region of high to low concentration, called as mass transfer. Clear है? Okay, now second is airy diffusion. ये तो मैकेनिज्म है, इसके थ्रू मास का ट्रांसफर होगा, और मास के ट्रांसफर होने के लिए ड्राइविंग फोर्स चाहिए ना, लेकिन ये जो मैकेनिज्म है इसकी वजह से मोमेंटम का, मास का, एनर्जी का ट्रांसफर होगा, बट जो नेट ट्रांसफर होगा मॉलिक्यूल्स का दैट इज फ्रॉम द रीजन ऑफ हाई टू लो कंसंट्रेशन. क्लियर है? यस नो? एनी प्रॉब्लम टू एनीवन? नाउ कम टू एडी डिफ्यूजन. एडी डिफ्यूजन इज बिकॉज ऑफ रैंडम एंड माइक्रोस्कोपिक मूवमेंट ऑफ द मॉलिक्यूल्स ड्यू टू एडीज. यस और नो? राइट डाउन प्लीज. एडी डिफ्यूजन by random macroscopic fluid motion, by random macroscopic MACRO macroscopic fluid motion. Clear है? बोलो. The two mechanisms of the mass transfer we have seen here, one is called as molecular diffusion, other is called as eddy diffusion or turbulent diffusion sometimes, and they are only because of presence of eddies. Now okay, when the eddies are there, when the bulk flow is there, what happens? Listen clear. When there is a bulk flow, when anyhow there is a bulk flow is going to be involved in mass transfer operations. When the bulk flow is involved, then total rate of mass transfer of each species is going to be enhanced or decreased. Yes or no? When the bulk motion is going to involve, listen carefully, when the bulk motion is going to involve, the total rate of mass transfer of individual species is increased or decreased by the bulk flow. Either increase or decrease. Yes or no? Both is possible. I will discuss it. No, not always enhanced. Not always enhanced. भाई bulk flow हो रहा है, किसी का decrease भी होगा, किसी का increase भी होगा. It may either increase or decrease. Listen carefully. Not always increased. I will discuss it. Listen, please write. Not always enhanced. भाई जो bulk flow के साथ में होगा उसका तो increase करेगा, जो opposing में है उसका क्या होगा? मान लो bulk flow इधर move कर रहा है. And I told you, due to molecular diffusion and eddy diffusion, through both mechanisms of mass transfer, the molecules can be moved in either direction. Molecules can be moved from the low to high and high to low. Molecules can be moved in the either direction. किसी भी डायरेक्शन में molecules move कर सकते हैं, but net movement होगा किसी एक डायरेक्शन में. That is different thing. Yeah, but when the bulk flow is there, when the bulk flow is going to be associated, then the total rate of mass transfer, of each species is going to be either increased or decreased. And that is called third mechanism of the mass transfer. Clear है? बोलो. Clear? Write down. Write down. When bulk motion is there, then the total rate of mass transfer of individual species or each species will get either enhanced or decreased. When a bulk flow occurs, then the total rate of mass transfer of individual species is increased or decreased by this bulk flow, which is called as third mechanism of the mass transfer. Okay, बोलो. Any problem? I think this will no any problem. So mechanism is there, basically two mechanisms, but one more mechanism is very important, that is not directly involved, but indirectly it can increase or decrease the rate of mass transfer of individual species. It can either increase or decrease, because whenever bulk flow is there, that bulk flow will either enhance or decreased the total rate of mass transfer. Am I right? कोई दिक्कत यहाँ तक? That is called as third mechanism of mass transfer. जैसा कि सब में था, तीनों मैकेनिज्म था ही, है ना. तो माय डियर स्टूडेंट, मॉलिक्यूलर डिफ्यूजन कैन टेक्स प्लेस इन आइदर फ्लूइड स्टैग्नेंट और इन लेमिनार एज वेल एज आइदर इन टर्बुलेंट. है कि नहीं? तीनों में हो सकता ही नहीं हो सकता. बताओ. molecular diffusion occurs in a fluid that are stagnant or in laminar or in turbulent. Yes or no? Eddy diffusion occurs in the fluid which are in turbulent flow. Eddy diffusion can only be exist when the fluid is in turbulent flow. Write down points. Eddy diffusion can exist only when the fluid is in turbulent mode. Means when eddies are going to be takes place. When the eddies are there. Okay. Now, when the mass is transferred, listen. When the mass transfer is taking place in the turbulent flow, flowing over a solid surface. Suppose this is the solid surface. Try to understand, sir. हर चीज लिखना नहीं. Just आप खुद सोचो, आंसर दो. When the turbulent flow is there and this turbulent flow is flowing over a solid surface, where the turbulent flow is taking place over the solid surface, for example, flat plate or through the sphere, even the flow is turbulent, but any region of the fluid near the surface of solid, they are assumed to be stagnant or in laminar. Yes or no? Bolo. Even the outside flow is turbulent, the eddies are there. I have told you already. Even the eddies are there, but the region which are called viscous sublayer region, either in the pipe, also you can say in the pipe, this viscous sublayer region is there. Even the flow is turbulent here. Even the flow is turbulent in the main core, but the region which are close to surface, the effect of turbulence is going to dampen. Eddy diffusion is going to dampen. Yes or no? So even the flow is turbulent. Even the mass transfer, I am talking about turbulent flow. Even I am talking about the mass transfer in turbulent flow. But if the turbulent flow is going to take place over the solid surface, then the effect of eddies diffusion is going to be dampened when we are coming close to the boundary, close to the surface. Yes or no? When we are coming close to the surface, either in the pipe or the mass transfer through the flat plate or mass transfer through a sphere or cylinder. Okay? So these terms are very, very important. So in viscous cellular region, any mass transfer is taking place only by molecular diffusion, not by eddy. Eddy diffusion has no any role. Clear? Because no eddies are present in the viscous cellular region. In the viscous cellular, any transport is only dominating because of molecular properties called as molecular diffusion. So even the bulk flow is turbulent. There is a bulk turbulent flow is there, but mass transfer, magnetic mass transfer close to the boundary, close to solid surface is going to be dominated by the molecular diffusion as compared to eddy diffusion. Clear? Now in general, what I can write here, listen, if Ni, if N is the total molar flux, write down please. Better is that types of fluxes. Write down heading is types of flux. Is this clear? अभी तक clear? मैंने तीन मैकेनिज्म को क्लियर किया है और तीनों मैकेनिज्म का जस्ट सेम एज ए हीट ट्रांसफर एंड मोमेंटम ट्रांसफर. राइट डाउन. नेक्स्ट इज टाइप्स ऑफ फ्लक्सेस. Types of flux. Now what is flux actually? I am talking about mass flux here. Types of mass flux or molar flux. The two types of flux is there. Flux means the transfer of the mass per unit area per unit time. How much amount of mass has been transferred per unit area per unit time. Okay, mass or moles. जो भी हो, mole transfer, तो molar flux, mass transfer, then mass flux. Clear? The two types of flux is there called as N and J. So if I am talking about flux of any species height, Ni and Ji, let's say Ni is the molar flux of a species I. It is also called as molar flux of a species I. So what is the difference in these two? It is also molar flux. It is also molar flux. Unit is mole of I transfer per unit area per unit time. है ना. Now it is again mole of I get transfer per unit area per unit time. Both are the flux and both are the molar flux, Ni and Ji. What are the basic difference in these two, Ni and Ji? Now I can define flux means transfer of any species. Yeah, the reference frame are different. Means we are going to measure ki how much moles of a species has been transferred per unit area per unit time when the observer, when the reference is stationary, when the reference is fixed. Clear hai? When the reference is fixed here, both are the flux, there is no difference. The only difference is of the reference plane. So if you are going to measure ki how much moles has been transferred through this area in that time when the reference frame is stationary, means when the observer who is going to measure the moles of transfer of a species is stationary. Clear? For example, if suppose you want to measure the speed of a train, if you want to measure the speed of a train, you know, now the two method is there. One, you are stationary, you are just standing on a platform and you are measuring what is speed. Second is you are moving in other train, you are moving in other train, and if the train in which you are, the train in which you are, let's say two train is there and you want to measure speed of train of A, and here you are also on the second train which is moving on the other track and its speed is 20 km per hour, and here its speed is 40 km per hour. Now please tell me what is the relative speed of this train. Obviously, and other is that you are stationary at this point, your velocity is 0. Here your reference frame, here you are moving with some velocity and here you are fixed. In both cases you will measure different velocity, yes or no? In both cases you will measure different velocity. When you are moving with some velocity, when you are moving with some reference frame which is moving with 20 km per hour, then you will observe the rate of transfer of train A is 20 km per hour only. But when you are stationary and now you are going to measure, then it seems like 40 km per hour. Yes or no? So in both cases you will find two different speed. Similarly, if you want to measure the flux, if you want to measure flux of any molecules which are transferring from the region of high to low concentration, when you want to measure the rate at which the moles or species are going to transfer, then you will find two different rate or two different flux. Two different flux you will obtain. Are you getting a point? Yes or no? Suppose here this is the system is there. Here the high concentration of the molecule is there. Very high concentration, very high dense, high concentration means more number of moles in given volume, and here less concentration, less dense is there. Then there is net transfer. Although these molecules which are dense will also transfer here, and some molecules will also transfer here. But net transfer of these molecules is only from the left to right. Am I right? And net transfer of these molecules, that is better to understand in this way. Listen. Suppose you have a compartment. Try to understand, sir. Now just I am saying what is the need of this. I am just saying, Mr. Prajapati, just wait. Suppose you have a two compartment. Now two compartment is there and that has been divided by at a given temperature and pressure. Now this consists of two components. The two species are there. Now here these are the A molecules, and here also some molecules are there, but they are not as much as here. Now here B molecule is also there, but here B molecule is very high, right side. Clear? Now this is B. Now it is a mixture of two species. This system consists of two species, and in the left A and B are there and right A and B are there. In the left, in a given volume, what is concentration? Mole per unit volume. So more number of moles of A species are there in a given volume as compared to right side. Am I right? Yes or no? In the left side, more number of molecules of A is there in given volume as compared to right side. Then the concentration of A in the left is more than the right. Yes or no? Concentration of A in the left is more than the right. Similarly, in the right side, more number of molecules of the B are there in given volume. It means concentration of B in the right side is more than the left side. Clear? When we are going to remove this barrier, what happened? There is a natural tendency is there. There is a natural tendency is there, and the natural tendency is what? There is a natural tendency that molecules are moving randomly at the microscopic level. Are you getting my point? Molecules are moving at the microscopic level, but the net movement is from the net movement of the A. Although I am not saying, listen, some A is transferring from the left to right and right to left as well. B is also transferring from the left to right and right to left as well. But the net transfer of A is from left to right, and net transfer of B from the right to left. Yes or no? And I told you, in the molecular diffusion and eddy diffusion, that molecules can be transferred in either direction. But I am talking about net movement. The net movement of A is from the left to right and B from the right to left. And this transfer will continue until the concentration is not become uniform. And since there are single phase is there, in single phase, when the concentration become equal, C of A in the left, C of A in the right, C of B in the left, C of B in the right is going to be equal, then chemical potential will also be equal, then no further mass transfer is taking place. Clear? Now I am talking about the flux. So as I told you, the net transfer of the A, Mr. Prajapati, I am more interested in the flux. What is flux? Rate of mass transfer, or rate of mass transfer per unit area. Through unit area, how much mass has been transferred? Let's say I am going to define this as a, after removing, suppose as we have removed, I am talking about, I am mainly concerned about this area called as dA. Through this area, in given time, how much A has been transferred, because net transfer of A is from the left side and B is from the right to left. Am I right? B and A here. Net transfer of the A is from the left to right and net transfer of the B is from the right to left. So if I am talking about what is the rate of transfer, what is net rate of transfer of the A from the left to right, that I can measure in two ways. In two ways means when the observer is stationary here, when the observer is in the fixed reference frame, when we are going to measure the flux with respect to fixed or stationary reference frame, means observer who is going to measure what is the transfer, what is rate of transfer of the A through this area, it is called as N. Okay. Now, and if suppose you are going to measure the flux of A again, but when the observer is moving with some velocity, when the observer is also moving with the velocity of the molecules of A is moving along with that A, observer is also moving, then what happens? You will find two different flux. Is it right? And what is the requirement of these two flux? I will discuss later on. Is this clear? Same thing is for the B as well. Same thing for the B as well. So in this case, there is no any, my dear son, listen, in this case, the molecular diffusion is taking place and the two types of flux is going to be found, N and J. One, when the observer is stationary, or when we are going to measure the flux with respect to stationary reference frame, flux of species A. Yes or no? Second is when we are going to measure the flux of A when the observer is moving with some average velocity, or when the observer is moving with some reference frame, but reference frame is moving, not stationary, then other value of flux we got. Clear? Hai? So please write down two types of flux is there, Ni and Ji. It is the flux, molar flux I am talking about, flux of species I. You can add this point, species I, with respect to species I with respect to stationary reference frame. Reference frame. And second is or with respect to stationary observer. Now Ji is the flux of species I with respect to moving reference frame. Moving means it means when observer is moving with some average velocity. You can write when observer is moving with some average velocity. Two types of flux we define, Ni and Ji. Clear? I is the species. For example, in previous example, two species are the A and B. So it is a flux of all A. If JB, then flux of all B with respect to moving reference frame. Clear? Ni and Ji. Now, as I told you, Ni is also called as absolute flux. Also called as absolute flux of species I. Absolute flux of species I. Why absolute? Because it is going to be observed when the observer, and in order to design the mass transfer equipments, we should only know Ni, not Ji. Because always we are more interested about the what is the flux when the observer is stationary, because in design of equipment that flux is important. Ni, am I right? Below. In design of equipment, which flux is important? Ni is important as compared to Ji. We don't want to Ji, we just want to know Ni, because in design of equipment you want to find the rate of mass transfer or rate of mass flux or molar flux with respect to stationary observer. Now it is called absolute flux, and it is also defined as concentration of species I into the absolute velocity of that species I. Ci into Vi. Please write down. And why it is absolute? Because it is total flux. It is also called total flux of species I. It is called as total molar flux of species I. Absolute में क्या बोलना? Total molar. Why total molar? Listen, it is very interesting. Ni, absolute flux of species I, and it is also called total molar flux of species I. It involves two terms: total molar flux of species I. That's why we are in designing of equipment. अगर पूछता है कोई कि why Ni is important for design of equipment, then you should say कि sir Ni includes total molar flux of species I. Then the question is, what is meaning of total molar flux? Total molar flux means, sir, the transfer of species I due to bulk motion as well as due to molecular diffusion. It involves two types of diffusion. Two types of mechanism is involved in this case. This Ni involves two mechanisms. That's why I'm talking about total molar flux of species I. Absolute flux means total molar flux. Simran, just wait for a moment. I am discussing it. Yeah, very good. Ni is the absolute flux because it includes total molar flux. One is due to bulk and other is because of total molar flux. Total molar flux, for example, total momentum transfer. Total momentum transfer is because of, suppose, just simple. What is Ni and what is Gi? You can relate with this example. Suppose if I have a thermal energy, because every molecules are going to transfer, move randomly at the microscopic level because of its thermal energy. So I have a thermal energy, I am energetic, I will move here and there. So I am moving just, so it is my own characteristic feature. Am I right? This is my own characteristic feature, and any transfer of the species by their characteristic feature is defined by the Gi, called as fixed law of diffusion, called as molecular diffusion. Am I right? Below. Yeah, very good, Ritik. That I am going to show you. Ki Gi is a measure of diffusion capability, or you can say characteristic feature of the species. Ki what is the characteristic feature of the species to diffuse? Yeah, excellent, Ritik. Clear, Ritik? You have used the word capability and I have used the word characteristic feature. जो मेरा characteristic feature क्या है? Just like in the momentum transfer, I told you molecular momentum flux. If I want to transfer from our own, that is my own characteristic feature, and that is called as molecular momentum flux. Similarly, in the mass transfer, if any molecules are going to transfer because of its own thermal energy, that is its characteristic, that is its capability to transfer. That is called as characteristic feature of the substance or molecules क्लियर है? तो यू शुड अंडरस्टैंड सर, ji जो होता है, ji इज अ characteristic feature of the is a measure of ji is a measure of characteristic feature of the molecules to transfer or its ability to diffuse, and that is given by the fixed law of diffusion with respect to. Now I can define the fixed law of diffusion by the two ways. One is with respect to stationary and with respect to reference, but it is better to define the fixed law. Always the fixed law is going to define in terms of with respect to stationary reference frame, because I've told you. Clear है? Yes or no? And another is that एक तो हो गया, इट्स इफ यू वांट टू मेजर द कैपेबिलिटी ऑफ द मॉलिक्यूल्स टू डिफ्यूज, दैट इज गोइंग टू मेजर बाय द ji, कि इफ एनी ट्रांसफर ऑफ द स्पीसीज गोइंग टू टेक प्लेस बिकॉज ऑफ इट्स ओन कैरेक्टरिस्टिक फीचर, दैट इज मेजर बाय ji. तो why gi is required? Gi is important just to measure the ability of the material or characteristic feature of the substance to diffuse. Clear? Now, and why ni is important? Ni is important just to design the equipments to find the actual rate of mass transfer. We should go for the ni, not for the ji. Is this clear? Because ni includes total. Total means, as I told you, in the crowd I just going to transfer, I am just going to move from one point to other point by my own characteristic feature. And second is, since crowd is also moving, then I have the total flux. Suppose you are standing on the top, then total movement of mine is not because of purely my own feature, na? That is because of contribution of the two mechanism. One is called as due to bulk flow and other is my own characteristic feature. So if you want to measure the total rate of transfer of mine, that is because of my own feature, and second is by the bulk. Is this clear? Yes or no? Simran, clear hai? Yes or no? But if anyone want to measure my only characteristic feature, then what should they do? If any observer who wants to know any transfer of mine only because of my own ability, my own characteristic feature, what he should do? He should also move with the bulk of velocity, bulk average velocity of the molecules. Then only he is able to know what is my own potential, what is my mine potential. Clear है? बोलो. So if you want to nullify, if you want to cancel the effect of bulk flow in the total rate of mass transfer, what you should do? If you want to cancel the effect of bulk in the total rate of mass transfer, total rate of transfer of mine, what he should do? You should also move with the mass average velocity. Then only you are able to know what is my potential. Otherwise you are not able to know my potential. What is the features, what is the diffusing ability of any species? So if you want to know diffusing capability of the species, if you want to know the characteristic feature of the substance or species, then the observer has to move with the mass average velocity. Clear hai? Is this clear? Now it is clear why Na and J are important. Both have two different significance. J is a measure of characteristic feature of the substance, or its measure of diffusing capability of the species to diffuse, and Na is the important for design of equipment, because we are only in testing total rate of mass transfer, not by the own feature. No, कैसे भी हो रहा है हमारा mass transfer हो रहा है, उससे हमें कोई मतलब नहीं है. तो as far design of equipment is concerned, we should only bother about the total rate of mass transfer, called Ni of species. Clear है? Yes or no? तो characteristic feature of the substance is going to defined by the all molecular property, either the heat transfer for the mass and moment. In the heat transfer, the characteristic feature of the molecules for the energy transfer is defined by fixed law of Fourier's law of heat conduction. In the momentum transfer, by Newton's law of viscosity. In the mass transfer, fixed law of diffusion. The all characteristic feature of the substance to diffuse, to transfer the energy, mass and momentum is going to be measured by all molecular phenomena. In the heat transfer, Fourier's law. In the mass transfer, fixed law. In the momentum transfer, Newton's law of viscosity. Is this clear? बोलो. तो you can write here. यहाँ आपने GI लिखा है ना, अभी मैं लिखूंगा. It is called as total molar flux. Total molar flux of species I with respect to stationary reference frame, and This flux is important in design of equipments to find the total rate of mass transfer. You can write this flux is important. This flux is important in design of mass transfer equipments in order to calculate total rate of mass transfer of that species. Kajal, any problem? And that is actually Ci into Vi. What is Ci? It is concentration of species I in the mixture. Because if you want to suppose in this example where A and B are there, as you can see here, in this example, if you want to know what is the N of A, means by the yellow color Na, so this should be Ca into Va. What is Ca? Ca is the concentration of species, concentration of A in that localized point, किसी given point पे, in a given volume, because it is only at some certain, not in whole volume. This is Na in the only differential. If you want to find total, then we should go for the integration. That is different thing. So what is Ca? Ca is the concentration of all A in a given area, in given volume. And what is Va? Va is the, what is Va? Va is the average velocity of all A. Is this clear? Called as absolute velocity of A. It is the velocity of A which are going to be measured with respect to stationary reference frame. Clear hai? So Ca into Va, it is called as flux. Concentration into velocity will give the flux of A. Okay, what is the, for if this Va is the absolute velocity, it means velocity with respect to stationary observer, then if you multiply with the concentration, you will find out flux of A. Bolo. So Ni equal to Ci into Vi. Ci is the concentration of species I in a given region, and Vi is the absolute velocity of all species I, all species A in the previous example. And you can check the unit here. It is mole per meter cube, and this is called as meter per second. Mole per meter square per second called flux. तो concentration into velocity will give the flux. अगर ये mass flux हो क्या होगा? Velocity density into velocity, that's it. Rho v into area क्या देगा? Mass fluid क्या होता है? वही चीज़ है. ये Ni है, इसको अगर हमें मास में लिखना है, मोलर फ्लक्स है, मास फ्लक्स क्या हो जाएगा? Mi डॉट, दैट्स इट. चूंकि फ्लक्स लिख रहे हो तो क्या चाहिए? Mi, इट इज कॉल्ड Mi डॉट पर यूनिट एरिया. तो रो इंटू वी इंटू एरिया कैंसिल. रो इंटू वी, रो क्या है? मास डेंसिटी. ये क्या? मोलर डेंसिटी, दैट्स इट. तो Vi is the absolute velocity of species I in a given region. Average of the all, average velocity of all molecules of A in a given volume. तो Vi, क्योंकि एक ये Vi क्या होगा? जितने भी A हैं किसी given region में, जितने भी A के molecule की velocity होगी, उनका सबका average है ना? Absolute velocity of A और I. Now come to the Ji. देखो Ji, it is a measure of, this flux is a measure of characteristic feature of a substance I. Characteristic feature of species I. It means it measure of diffusion ability. It is a measure of diffusion ability. It is a measure of diffusion ability. It is a measure of diffusion ability, है ना? ये हो गया कंसंट्रेशन. जितने भी नंबर ऑफ मॉलिक्यूल्स ए के होंगे, चूंकि हमें निकालना है टोटल ए का फ्लक्स, तो हम क्या करेंगे? वेलोसिटी में पूरे कंसंट्रेशन का मल्टीप्लाई कर देंगे, क्या जाएगा? टोटल फ्लक्स आ जाएगा. दैट्स इट. समझ में आ गया? नाउ अगर आपको जीआई निकलना है, व्हाट यू शुड डू? इफ यू वांट टू मेजर द कैरेक्टरिस्टिक फीचर ऑफ सब्सटेंस ऑफ आई ऑफ ए स्पीसीज, व्हाट यू शुड डू? You should move with the average velocity. Yes or no? You should move with the average velocity. Bolo. If you want to know what is the characteristic feature of that substance, what you should do? This should be just common sense. It is Ci into Vi minus what? V star. And V star is the, it is the relative velocity of species I. It is relative velocity of species I with respect to moving reference frame. Yeah. Very good. That's it. Any problem? I think there should be no any problem. And this Ji may be negative or positive depending upon direction. बोलो अभी तो कोई दिक्कत? I think there should be no any problem. So this is a measure of characteristic feature of substance, or it is a measure of diffusion ability of the substance in the mixture. Now, and there is also called as diffusion velocity, called as term called as di, is called as diffusion velocity of species I. Diffusion velocity of species I. Species I का diffusion velocity क्या होगा बच्चे? Diffusion velocity of species I, di, this will be what? Vi minus V star, average velocity, where V star is the average velocity of the mixture. You can write called as diffusion velocity. V star equal average bulk average velocity. I am going to clear, don't worry. V star is the average velocity of mixture. Average velocity of mixture. Molar average velocity, yes. Molar. Everything I am going to write in terms of moles. Molar average velocity. And molar average and mass average velocity both are different. Mass तब होगा जब ये mass concentration होगा. ये molar concentration है, then it should be only molar average velocity. Is this clear? If you want to write each and every terms in terms of, every term I have written in terms of, everything I have written in terms of mole, molar flux, molar concentration, then it should be molar average velocity. Molar average velocity. What is the molar average velocity? I am discussing it. Don't worry. I told you now, if you want to know what is my feature, what is my ability to diffuse, then you should move with some velocity. Now, what velocity we should take here? We should go for the average velocity. What average velocity? Molar average velocity of all molecules A and B. Okay, now listen. I will discuss how can go for the molar average velocity. Then I can write Ji is equal to Ci into Di. Yes or no? Ci into Di. Di is called as diffusion velocity of species I in the mixture. Diffusion velocity, that is called as relative velocity also. Now, as I told you, when the bulk is moving, I have told you, if you want to find out the flux of species A with respect to species observer, you will find that contribution of two terms. One is its own feature, other is due to bulk flow. So how can you find the contribution of the bulk flow in the total flux? Anyone? How can you find the contribution of means flux of species I, rate of transfer of species I due to bulk flow? What I told you, this Ni, listen carefully, this Ni consists of two terms. One is due to molecular diffusion, clear? Any transfer, any flux due to molecular diffusion called diffusive flux. This is summation of diffusive flux. And second is called as due to bulk flow. Bulk contribution flux. Bulk contribution, please write the same. Molar diffusive flux, molar है, molar diffusive flux, molar bulk contribution flux or bulk contribution flux. Molar diffusive flux, it is a measure of characteristic feature called as Ji. Yes or no? This is Ji. Yeah, that is different thing. It is Ji. How can you find the bulk contribution? Bulk means when the bulk is moving. Bulk means A and B both is moving. Here in this example, if you want to find, if you remove the partition, then A is moving and B is also moving. Na? A is also moving, B is also moving. Here may be possible that total flux of A is, let's say, Na. Total flux is going to move in the left to right, and total flux of B in the right to left. If they are equal and opposite, then what happens? Total flux is equal to Na plus Nb. Total flux, not species. Total flux of species equal to Na plus Nb. Yes or no? Total molar flux, not of any species. Total I am talking about. Total molar flux of system, that is Na plus Nb. And if they are equal and opposite in the same direction, what happens? The contribution of the bulk flow is cancelled out. If Na equal to minus of Nb equal and opposite, then that there is no, means in this case Na and J are same. Means whatever we are going to measure with respect to series, same is the characteristic feature substance. Am I right? Na equal to J. But if they are opposite but not equal in magnitude, then what happens? Let's say this is 2 Nb. Sorry, if this is, let's say it is Na here and Nb here, and let's say Nb equal to, if Nb is found to be minus of 2 Nb equal to Na, what happen? Nb equal to Na, then what happen? NB is equal to found with 2Na. It means total flux is what? Total flux is N equal to Na plus NB. Now NB, Na, NB is equal to minus 2Na. It means N is found to be what? Minus of Na. It means it is going to move in the opposite of A. Means bulk is moving in the opposite. Bulk is moving in the opposite direction of A. Moving. Yes or no? जो bulk move कर रहा है वो opposite direction of A move कर रहा है. तो उसमें I told you ना कि when the bulk flow is associated, I told you, just recall, when the bulk flow is there, then rate of mass transfer of every species can either increase or decrease. Yes or no? Or rate of mass transfer of individual species, individual, not every, rate of mass transfer of individual species may either increase or decrease. तो इंक्रीज किसका होगा बच्चे? बी का. बट डिक्रीज किसका होगा? ए का. यस और नो? याद है? एवरीथिंग इज क्लियर? आई थिंक इट इज वेरी क्लियर. यस और नो? सिमरन, नाउ इफ NB is 0, then what happen? If NB is 0, it means for an observer, listen, just listen carefully. If NB is 0, NB 0 means what? For an observer, it is a flux of B with respect to stationary observer. It is a flux of B with respect to stationary observer. है ना? तो for an observer, suppose I am an observer, for me it seems that B is not moving. For example, try to understand, sir. So it does not mean that if NB is 0, it doesn't mean that there is no diffusion of B by its own feature. भाई NB आपको ही लग रहा है 0 ना? When the observer is on the top of the floor, suppose I am moving, but what happened? The opposite crowd will counterbalance my any movement. I am just want to move. I am moving actually. I am moving, but there is a equal and opposite current is there. If I am moving with 2 meter per second, if I am moving with 2 meter per second and the bulk is coming with the same rate in the opposite direction of 2 meter per second, what happened? Suppose I am moving with 2 meter per second in this direction. Now, and here the bulk is moving with 2 meter per second here also. Then for an observer who is sitting on the outside the system, for him it seems that B is not moving. Am I right? So it is indicating that, but it does not mean that B is not moving. B is moving, sir. B is moving actually. And if you want to know what is the flux of B because of its own feature, what you should do? If an observer is going to move with some velocity, then for him it seems that it is moving. Are you getting this? बात से दिखेगा. Now, इससे better example क्या? For example, listen. Suppose a fish is there. That is better example. If you have fish, this fish swims with 2 meter per second. Okay, and a current of the water is moving in the opposite direction of 2 meter per second. Listen carefully. If fish is moving with 2 meter per second and current of water is moving in the downstream direction with 2 meter per second, same velocity, what happened? My question is that if suppose a fish is moving in the water with 2 meter per second and a current is also moving with the velocity of 2 meter per second, for an observer, for a fisherman, the fish is stationary. Yes or no? For the fisherman, the fish is stationary. Why is it stationary? Because whatever the flux of fish because of its own feature is going to be cancelled. Its effect is going to be cancelled by the bulk flow of opposite direction. Mr. Babo, is this clear? So in this case, if the fish is, let's say, B, so NB is 0, yes or no? But JB is not equal to 0. JB is the diffusion ability of the fish. Fish is actually moving, trying to move here. And if you want to measure what is the diffusive flux of the B, what you should do? If you want to observe what is the flux of fish B, then if any object, if any person is moving, if fisherman start moving with the velocity of 2 meter per second on the boat. Now here listen, the second case, the same fish is here. Now here, now it is 2 meter per second in this direction. Now here the fisherman now start moving on the boat which is moving with the velocity of the current. It is again 2 meter per second. Now he is able to see, yes, he is going to, this fish is going to move with the velocity of 2 meter per second. Yes or no? Bolo bhai. Mr. Vaibhav, clear? So for an NB0, it means the any contribution of the flux because of concentration difference or because of own feature is going to be counterbalanced in the by the bulk flow. भाई NB0 नहीं, NB क्या बोले हो भाई? NB0 है, इसका मतलब JB0 थोड़ी ना यार. NB0 मतलब क्या है? NB क्या है? Flux of B क्या है? Flux of B is what? It is a flux due to two terms. Flux of B because of diffusive, means because of its own feature, and second due to bulk flow. When NB0, it means the any transfer of the B because of diffusive flux is going to be exactly balanced by the bulk flow. जितना ये जितने रेट से ट्रांसफर हो रहा है इस डायरेक्शन में, उतना ही रेट से बल्क फ्लो का ट्रांसफॉर्मेशन इस डायरेक्शन में हो रहा है. इस वजह से कैंसिल इफेक्ट हो गया. इक्वल एंड अपोजिट. In this example, I've told you a fish is there and fish is the B. Fish is going to move with its own velocity of 2 meter per second, and here, yes, obviously fish will stay there because it will cancel the effect. That's why NB equal to 0. No flux is there. Total flux is 0. Sir, listen. Fish is moving, and what is also moving? What happened? Fish is also moving. What is also moving? ये भी मूव कर रहा है, ये भी मूव कर रहा है, दोनों मूव कर रहा है. ऐसा समझो, ऐसे. Fish is moving 2 meter per second. Water is also moving 2 meter per second. Then what happened? What happened? For example, that is better to understand like that. Mr. Babo and Mr. Karthik. Suppose a train is there, you are here, A, and here the train is also moving the same speed of this. Sorry, train and earth. Train is there and train is moving on the पटरी क्या बोलते हैं, railway line. A railway line is also moving with the same speed of 20 meter per second, and this is the train like that, wagon. It is moving with 20 meter per second. It is not necessary. Now here it is also moving with the, now the railway line is also moving with the 20 meter per second in opposite direction. What happened? Both are moving now. For example, best example is treadmill. Have you seen treadmill? Best example is treadmill. Treadmill देखा है? You are moving, Mr. Karthik, or not? You are moving ना? You are not necessarily, you are moving. And the mill over which you are moving, it is also moving in the opposite direction with the same speed. What happened? बताओ. So for an friend who is outside the treadmill, for him it seems that you are standing, but actually you are moving ना? Oh, Anushka, Misra, ma'am, you are confusing. No. Now, another example is, in mall you might have seen the accelerator. If the accelerator is coming down with the 2 meter per second, and you are running from down to upside with the same velocity of 2 meter per second, what happened? You are moving now, you are running. You are running with the 2 meter per second. On accelerator on which you are running, also moving with the 2 meter per second, but in opposite direction, what happened? For you, it seems that you are moving, obviously moving. But for an observer who is outside the system, for him, it seems that, for him or her, it seems that you are on the same position. Is this clear? Now it is clear to everyone, Mr. Karthik. So you can't say fish is moving. Now clear hai? So why the NB is 0? Because whatever the contribution, the flux because of its own contribution, because of JB, diffusive flux is going to be balanced by the flux of the same species because of bulk flow contribution. It is equal and opposite. That's why it seems that it is going to be 0. Clear for an observer. But JB is not 0. JB is diffusive flux is not 0. Clear? अभी तो डाउट नहीं है किसी को? Okay, now the question is that how can find this? So I've told you just Ni is equal to summation of two terms, that is called as diffusive flux, molar diffusive flux, called as ji. This is the flux of species I with respect to moving reference frame. And how can find out this? This is the contribution of species I because of bulk flow. Bulk flow means n. N is the total flux. But what is the contribution? It is a total flux, na? How can find the any contribution due to bulk flow of species I? Please tell me. This is total flux of Na plus Nb, or summation of Ni, you can say. Summation of Ni, where I equal to 1 to n. N is the all number of species present. It is total flux, am I right? Na plus Nb. If 3 are there, Na plus Nb plus Nc. And if you want to find out it is total flux, then what is the flux of species I due to bulk flow? Total bulk flow. Anyone? Yes, we should multiply with corresponding mole fraction. That is called either Xi or Yi. If liquid phase, then Xi, gas phase, then Yi, by its mole fraction. Then you can find the flux of species I due to bulk flow contribution. Now, so please write down total flux of species I is equal to molar diffusive flux. Second is called as summation of Ni into Xi is called as summation of Ni into Xi is called as bulk contribution flux. Of I. I think there should be no any problem. Yes, sir. That's why it seems to be stationary for an observer who is outside. Molar bulk, yes, molar only. Molar bulk contribution flux of species I. Now, as I told you, in general, the same thing you can also obtain by like that. Ni equal to Ci into Vi. Now, Ji equal to Ci into Di, diffusion velocity, Ci into Vi minus V star, molar average velocity. Clear? How can find this equation? I am going to show you. Now, what is the relationship between Ni and Ji? If you want to find out, it is equation 1, equation 2. Now, Ji is found to be Ci into Vi minus Ci into V star. Ci into V is called Ni, am I right? Ni minus Ci into V star. This is called as Ji. Then this implies that Ni equal to Ji plus Ci into V star. I think this will no any problem. And V star is the bulk average velocity. And if you are going to multiply with concentration, we will find this. I think, is this clear? Have you written this? Now, how can as my dear student, you know very well, the total molar flux N is equal to Ni, N is equal to summation of Ni's from I equal to 1 to all number of species present in the mixture. Then total molar flux I can write into total concentration. Yes or no? Total molar flux I can write here because it is not 5 species. Total concentration into molar average velocity, V star. Total concentration, which is called summation of CI's. C1 plus C2 plus C3 plus C4. Total concentration, C. Am I right? Yes or no? Please tell me fast. Total concentration. And what is Ni? Summation of I equal to 1 to N. Ni equals Ci into Vi. That's it. Then how can I find the V star? Then V star I can find out Ci into Vi upon C from I equal to 1 to N. And you know Ci upon C is what? V star I can write summation of Ci upon C into Vi. I equal to 1 to N. Ci upon C is called as mole fraction because molar concentration upon total molar concentration. Molar concentration of species I upon total concentration is called mole fraction. Then I think it should be V star I can write as summation of Xi Xi into Vi, or you can say it is equal to C1. Also you can write as summation of Ci into Vi upon total concentration. Both are same. And if liquid phase, then Xi, otherwise gas phase, then you can write as a Yi. I think this is the way how can find the molar average velocity. बोलो clear? देखो इधर से पकड़ो उधर से पकड़ो, बात देखिए. तो if the concentration of species in the mixture, suppose आपके पास 3 species है, A है, B है, C है, तीनों का दिया हुआ concentration और तीनों के दिया हुआ वेलोसिटी, एब्सोल्यूट वेलोसिटी दिया हुआ है. माय डियर, व्हाट इज दिस? Ci into Vi is equal to summation of Ni, yes or no, upon Ct. Also, दो कोई भी लिख सकते हो आप, आपकी मर्जी है. Because Ni is the concentration into absolute velocity. So this is also called as Ni, summation of Ni upon Ct. Please put here in this equation. So Ni equal to Ji plus Ci into V star equal to summation of Ni upon Ct. Ni is equal to Ji प्लस सी आई अपॉन सी टी इक्वल एक्स आई और वाई आई समेशन ऑफ एन आई. ये तो मैंने ड्राइव किया था अभी. ये कौन सा टर्म है? मोलर डिफ्यूजन. ये क्या है? बल्क फ्लो कंट्रीब्यूशन है कि नहीं? यहाँ से उठा के यहाँ कर दिया, आएगा ही भाई. कॉन्सेप्ट तो सेम ही है ना, इधर से करो उधर से करो, बात एक ही चीज है. बोलो क्लियर है? तो दिस इज एक्चुअली माय डियर स्टूडेंट, इन दिस केस वी हैव नॉट कंसीडर एनी इरीज ना. तो देखोगे दो टर्म आगे, बट that is very important, that is in the same direction. No? The two contribution is there, Ni, flux of species I in a given direction. So it is a diffusive flux in the same direction and bulk flow in the same direction. Okay. इरीज का रोल कब आएगा बच्चा? इरीज का थियोरेटिकली हम कहें तो ये तो न्यूमेरिकली है किसी स्पीसीज आई का किसी गिवन डायरेक्शन में, बट थियोरेटिकली व्हाट आई कैन राइट कि टोटल मोलर फ्लक्स ऑफ स्पीसीज आई इज इक्वल टू फ्लक्स ऑफ स्पीसीज आई ड्यू टू डिफ्यूजिव फ्लक्स, ड्यू डिफ्यूजन, सेकेंड ड्यू टू बल्क फ्लो एंड थर्ड इज बिकॉज ऑफ इडीज. है कि नहीं? बोलो. अगर हम इन जनरल लिखें टोटल मोलर फ्लक्स ऑफ स्पीसीज आई इज इक्वल टू मॉलिक्यूलर डिफ्यूजन फ्लक्स ऑफ स्पीसीज आई प्लस एडी डिफ्यूजन ऑफ स्पीसीज आई एंड प्लस बल्क फ्लो फ्लक्स, बल्क फ्लो कंट्रीब्यूशन फ्लक्स. है कि नहीं? नाउ लिसन. That's a good question. This equation is related for convective mass transfer. Sir, what is convective mass transfer? Actually, convective mass transfer is nothing special. I've told you now, whenever any bulk motion is there, when here the any motion is only, listen, in this case, whatever bulk motion I have discussed, in this case, whatever example I have told you, in this, there is no any motion because of pressure difference or energy difference. Yes or no? Bolo. Try to understand, sir. Whatever the example we discussed, whatever the total flux I have discussed here, Ni like that, Ni equal to Ji plus N into Xi. That I told you, in this case, whatever the total flux I am going to consider, that is because of flux of A and B. Huh? So this bulk flow is not at the microscopic level. That bulk flow is not going to induce because of external agency like pump, blower or because of pressure. बोलो है क्या? मैं आपसे सबसे पूछ रहा हूं इस एग्जांपल में. नाउ फिजिकली इट इज वैलिड, बट ट्राई टू अंडरस्टैंड दिस एग्जांपल. इन दिस एग्जांपल हियर द बल्क फ्लो टर्म इज नॉट इंडिकेटिंग यू कि फ्लूइड इज मूविंग. फ्लूइड इज नॉट मूविंग सर. हियर इज दिस फ्लूइड इज मूविंग. whatever example I told you, actually molecules are moving, and molecules are always moving at the microscopic level. There is no any bulk flow at the microscopic level. It means there is no any bulk flow because of pressure difference like pump, blower and compressor like that. Clear? Yes, it is just natural bulk flow, spontaneous bulk flow of A and B. And sometimes bulk flow contribution may be there, may not be there. For example, in equimolar counter diffusion, what happened? Bulk flow contribution is not there because N equal to minus of NB. है कि नहीं? And sometimes this term is not there. When N equal to minus of NB, when the total flux of A and total flux of B are equal and opposite, then their contribution is 0. Okay? और वैसे भी देखो. Now it is just mathematically. What is physically? Physically now the same equation, but in physical form I can write. Now when I am going to write, yes, microscopic means what? Mr. Sahil, I told you, sir, you have seen the examples. Here molecules are moving, sir. In this example, molecules were moving, sir. I have shown, sir, white and black molecules जो हमने दिखाया था ना, उसमें molecules move कर रहे हैं. No bulk motion, no any microscopic motion is there, sir. हमने कोई पंप नहीं लगाया कि मूव कर रहा है लिक्विड यहाँ से वहाँ पे. No, sir, not like natural convection, please. Not like natural convection, sir. Natural convection is not. You should not confuse with that. Natural convection is always because of difference in density or difference in concentration. Not don't confuse. Mass transfer can also be occur in the natural convection. If suppose the fluid layer are two different temperatures, then two different temperature, two different densities are there, then different density means different concentration, then there is again mass is going to transfer. Don't confuse with the, this is just a molecule natural process. Clear? Now, so when I am going to write theoretical definition of total flux Ni, then theoretical definition says, which is going to be valid in all cases. For example, in a room, molecules are moving here and there. Suppose you have a gas, you have entered two gas in this room. Although fan is off, everything is off, but still the movement is there, bulk flow is there. No, that bulk flow I am talking about in this example. Sir, molecular diffusion के लिए medium molecular diffusion तो कहीं भी होता है sir. Molecular diffusion is possible. I told you, मैंने वही बताया, molecular diffusion is possible in the laminar, in the stagnant, in turbulent as well. तीन मैकेनिज्म मैंने आपको बताया सर. molecular diffusion तो तीनों जगह होगा. When the fluid is stagnant completely, then only molecular diffusion. For example, in this case, here molecular diffusion is there and bulk flow also there. Okay, bulk flow contribution. Three mechanisms is there. Then two mechanisms is there here, but it is or not there. But that bulk flow is what? Two types of bulk flow is there. You can also write if you want. Yes, it includes when equimolar counter diffusion is there. When equimolar counter diffusion is there, Mr. Divakar, when equimolar counter diffusion is there, then in this case Na equal to only total flux equal to only where molecular flux. When I told you, sir, Na is equal to Ja plus Na plus Nb into Xa. When Na equal to minus of Nb, this term is 0. Now here it is only purely by molecular diffusion, but it is not general, sir. It is not general. It is in some cases. Yes, Umar, are you getting? Here the bulk meaning is there only. In this case the bulk meaning is only this. Clear? अभी समझ गया? अच्छा. Now the question is that, can I apply this in the laminar flow and turbulent flow? Yes, I can apply, but I will not apply this form. I will apply in this way. The total molar flux equation I can't apply, but physically I can apply. Total molar flux of species I is equal to molecular diffusion of I plus bulk diffusion plus eddy diffusion in general. When laminar flow is there, अब देखो यहाँ पे ये जनरल है, यहाँ से समझना. When laminar flow is there, this term is 0. Then only these two term is there. Okay. When laminar flow and stagnant medium is there, then this term is 0. When no eddies are there, then only you should bother about these two. Clear? अब समझ लो एक बार. Now, total molar flux of species I means mass can be transferred by three mechanisms. मैं स्टैटिक से बोल रहा हूँ. Mass can be transferred by three mechanisms. One is because of molecular diffusion. Second is because of bulk, means due to velocity, and third is because it is not there in the laminar and stagnant medium. Okay. अब मेरी बात समझो. This you can apply this equation. This you can apply in the laminar, in turbulent as well as stagnant. कहीं भी लगा लो. But when we are going to write this in this form, when we are going to write this equation in this form, that I can only use in this form. In which case, when the fluid is stagnant. Are you getting a point? Yes or no? समझो बात को. Physically you can apply anywhere, but when we are going to write this physics into mathematics, that I can only write in the form of, in the case of stagnant medium, means when the bulk flow is only because of molecular motion. Clear? Clear है? बोलो. अब शायद समझ रहे होगे आप. एग्जाम्पल दूं मैं? देखो, जैसा कि मिस्टर दिवाकर, I have taken example of plate is there. Over the plate, liquid is going to fall. है ना? This is liquid. And over this we have applied the momentum balance. So two types of momentum transfer is there. We have used the differential element. This was y and this was x. याद है? तो हमने इस पे लगाया था मोमेंटम बैलेंस, याद होगा आपको. तो here it was found to be tau by x, y plane x direction, tau by x, and here tau y x plus del tau y x over dy, जो भी लिखा था हमने, है ना. और एक क्या था? This is because of rho u into dA into u, momentum flux due to bulk flow. Momentum flux, this is the momentum flux due to, it is called as molecular momentum flux, and this is called as convective momentum flux due to bulk flow. Am I right? Yes or no? हाँ बोल सकते हो, लेकिन इक्वेशन जब व्हेन वी आर गोइंग, ये जो इक्वेशन के फॉर्म में जो डिफाइन किया ना उसको नहीं ले सकते हो. तो यहाँ पे दोनों तो आ गया, तो क्या बोलोगे? टोटल मोमेंटम फ्लक्स, टोटल मोमेंटम फ्लक्स इज इक्वल टू व्हाट? बोलो. टोटल मोमेंटम फ्लक्स इज इक्वल टू नेट रेट ऑफ मोमेंटम ड्यू टू नेट रेट ऑफ मोमेंटम ड्यू टू molecular flux plus net rate of momentum due to convective flux, advective flux, a bulk flow. Net rate of momentum due to advective flux और bulk flow. लिख सकते हो ना? बताओ. Bulk flow मतलब bulk flow plus molecular flux. Same thing if I'm talking about mass transfer. If I'm talking about mass transfer, what happen? ये laminar flow है, समझो. Now if I'm talking about laminar flow, mass transfer in the falling film. Have you seen about falling film? बोलो. सब कुछ मैं कर दिया रिलेट. अब समझना और समझ लो, बहुत ही इजी वे में. कहीं भी आप पूरे बुक पढ़ लो, ट्रिबाल पढ़ लो, पता नहीं क्या क्या पढ़ लो, कोई भी क्लियर मुझे बताओ. मिस्टर कार्थ क्लियर? नाउ if I'm talking about mass transfer in the falling film, what happened? In this case mass transfer, two types of mass transfer is there. If I am considering कि in y direction, if in y direction I am considering only, listen, although listen carefully sir, in y direction the mass can be transferred by two way. In y direction mass can be transferred by two way. What are two mechanisms? By molecular and by bulk. And since no bulk is there, because fluid तो मूव उधर नहीं कर रहा है और होगा भी तो बहुत कम होगा, तो केवल, लेकिन है दो ना. बोलो. There is two ना. In any direction the mass can be transferred or momentum can be transferred by two mechanisms when no eddies are there. One is molecular and bulk. So in y direction molecular plus bulk. Okay, in x direction what happened? Again molecular plus bulk. Am I right? Bolo. I am talking about mass transfer. Molecular plus bulk. Due to bulk means due to velocity. Molecular, and here velocity is not of the molecule. यहाँ पे तो वेलोसिटी किसकी बात कर रहा हूं मैं? अच्छा अब सुनो ध्यान से एक बार, मैं वही बोलना चाहता हूं सर. यस सर, बिकॉज यहाँ पे पंप लगाया सर, ये मूव हो रहा है ग्रेविटी के अगेंस्ट में, कोई फोर्स लगा हुआ है उसकी वजह से मूव हो रहा है. समझो ना बात को सर. अब क्वेश्चन मार्क क्यों लगाते हो साहिल यार? तुम हर जगह क्वेश्चन मार्क लगा देते हो यार. तुम इसलिए तो तुक्का मार रहे हो. कोई क्वेश्चन मार्क नहीं लगाता, तुम क्वेश्चन मार्क लगा देते हो. मतलब तुम गेस से पूछ रहे हो तुक्का मार के. ओके नाउ अब मैं बात करूं टोटल net rate of mass transfer. What should I write? Net rate of mass transfer in x direction plus net rate of mass transfer in y direction. Am I right? Net rate of mass transfer in x plus net rate of mass transfer in y. ये तो का बहुत ही चीजें ना क्लियर करता हूँ, बहुत इजी है, कहीं भी डाउट नहीं आएगा. इन y डायरेक्शन नेट रेट ऑफ मास ट्रांसफर इन एक्स मतलब क्या? मतलब आउट माइनस इन एक्स. नेट का मतलब क्या? आउट माइनस इन. तो एक्स में क्या लिखोगे बच्चे? नेट रेट ऑफ मास ट्रांसफर इन मास ट्रांसफर at x plus dx minus rate of mass transfer in at x plus dx minus rate of mass transfer at x similarly in the y. ये तो लिखोगे. अब मैं ये पूछना चाहता हूँ आपसे, बताओ क्लियर है? नो नेट राइट दिस. आर गेटिंग पॉइंट? यस नो. नेट रेट ऑफ मास ट्रांसफर क्या होगा? नेट एक्स में क्या होगा? यानी कितना आउट माइनस इन. इन एक्स में आउट माइनस इन, आउट minus in, out minus in, out due to 2. Okay, now if I am going to consider no bulk flow. If there is no bulk flow in x direction, in y direction, what you should write? Bolo. If there is no bulk flow in y direction, then it is only because of molecular. ठीक है. अच्छा, यहाँ पे क्या है? In this direction, in x direction, there is no mass transfer because of molecular diffusion. I am going to assume कि negligible is there. No axial diffusion, no axial molecular diffusion in x direction. Then only is because of velocity. तो क्या लिखते हो आप? Ca into what? Concentration of A. Let's say हम A diffuse हो रहा है यहाँ पे, तो Ca into V, Ca into Va लिखते हो? बताओ. Ca into Va at Z, at x. ये क्या हो गया? Ca into Va at x plus dx. Am I right? Yes or no? Because you know, due to velocity, if you are going to apply species balance, क्या होता है species balance बच्चे? In species balance, due to bulk flow, and Va is the velocity of the fluid. Am I right? Here I am talking about, here Na is equal to Ca into Va only. तो मीनिंग तो वही आ गया ना बच्चे. आप ऐसे देखो ना, जो Na को मैंने डिफाइन किया था क्या पता था? Ca into Va. तो Va इज द एब्सोल्यूट वेलोसिटी ऑफ मॉलिक्यूल्स था वहां पे. यहाँ पे क्या? इट इज द वेलोसिटी ऑफ, और जो पूरा A है, इट इज सिंपल वेलोसिटी ऑफ द होल लिक्विड. तो Ca इंटू वी एवरेज हम यहाँ देंगे. ए की बात ही नहीं कर रहा हम, पूरा बल्क जो मूव कर रहा है Ca इंटू. तो अल्टीमेटली क्या हो गया? वही तो बल्क फ्लो आ गया ना बच्चे. बोलो. तो कंसंट्रेशन इंटू वेलोसिटी विल गिव यू. तो वेलोसिटी इज नॉट ऑफ एनी ए स्पीसीज हियर. हियर इट इज वेलोसिटी ऑफ बल्क लिक्विड. यहाँ पूरा बल्क मूव कर रहा है. तो हियर आई एम राइटिंग एवरेज वेलोसिटी Ca इंटू वी बार. समझ गए? Ca इंटू वी बार, Ca इंटू वी बार एट एक्स प्लस डी एक्स. तो अल्टीमेटली मेन तो वही हो गया ना. इसका रिजल्ट क्या हुआ? कि फ्लक्स डिफ्यूजन ऑफ ए ड्यू टू बल्क फ्लो, यस, ड्यू टू बल्क फ्लो एंड बल्क फ्लो. बट यहाँ पे जो है, आई एम नॉट गोइंग वी, आई एम गोइंग टू राइट वी बार, एवरेज वेलोसिटी ऑफ लिक्विड विच इज फ्लोइंग आउट. तो जो एवरेज वेलोसिटी से निकलता है, दैट इज कॉल्ड एज. नाउ अभी क्लियर हो गया सबको? बताओ, अब समझ गए? तो कॉन्सेप्ट वही, थ्योरेटिकली यू कैन अप्लाई, बट न्यूमेरिकली यू कांट अप्लाई द सेम रिजल्ट. शायद इतना कहानी के बाद समझ गए होगे कि मतलब हम कर क्या रहे हैं. आई थिंक एवरीथिंग शुड बी क्लियर. ओके. तो जहां पे मास बैलेंस, मोमेंटम बैलेंस, एनर्जी बैलेंस जहां भी लगाओगे, तो ऑलवेज यू शुड बॉदर अबाउट द बल्क फ्लो कितना हो रहा है और मॉलिक्यूलर फ्लो कितना हो रहा है. ड्यू टू क्लियर. तो ये जो फॉर्म है बच्चे, व्हेन आई एम गोइंग टू राइट Na इक्वल टू J प्लस Na प्लस Nb into XA, this I can only write for stagnant medium or in total flux. When medium is stagnant and whatever the flux bulk flow contribution is there, that is only because of molecular total molecular motion. क्लियर है? अब तो क्लियर हो गया होगा बच्चे कि नहीं? अब मेरे ख्याल से. लेकिन मैथमेटिकली, फिजिकली जो होगा, you can use anywhere, as in the heat transfer, in the momentum transfer we already did. Okay, now write down fixed law of diffusion. Fixed law of diffusion. Heading is fixed law of diffusion. तो fixed law of diffusion, this is a measure of characteristic feature of a substance, है ना? Because this indicates you any diffusion because of concentration difference. Am I right? Yes or no? By this law, the molar flux of species I in the mixture molar flux of species I in the mixture with respect to what? Anyone? Fixed law of diffusion says by this law the molar flux of species I in the mixture I with respect to what? Which reference frame? Moving or stationary? Moving or stationary? Anyone? Molar flux of species I, yeah, very good, with respect to an observer moving with molar average velocity velocity in any direction, in a direction is proportional to concentration gradient in that direction. Concentration gradient in that direction. It means Ji Z, molar flux of species I with respect to moving reference frame moving with the molar average velocity in Z direction. Let's say Z direction is proportional to dci upon dz, concentration gradient in that direction, and the proportionality constant is Jiz minus dA B into dci upon dz, where minus sign indicates the concentration is decreasing in increasing z direction as it is. Clear? dB is the diffusivity of A in the species B, and that is called as for binary. This is the fixed law for the binary mixture. Then DAB, A तो आएगा नहीं, DI in the mixture लिख दो, general D लिख दो पहले, just only D. D is called as diffusivity of species I in the mixture. अरे यार DI लिख दो अभी फिलहाल के लिए. Diffusivity of species I. Okay, for binary mixture I can write Ji for binary mixture of A and B. You have binary mixture of A molecules and B molecules, then J of A in Z direction is equal to minus dA into B. It is called as diffusivity of A into B, called mutual diffusivity, mutual binary diffusivity, dCA upon dZ. Okay, please write. DAB is called as, where DAB is called as binary diffusivity of A in B, binary diffusivity of A in B, and every diffusivity have unit of meter square per second, dCA upon dZ. Am I right? Any problem? Then you know I can write Ni is equal to Na Ja plus Na plus Nb into Xa or Ya for liquid phase. Then J equal to minus dAb into dCA upon dZ plus Na plus Nb into Xa. This is the bulk flow contribution, it is a diffusive flux contribution. Now here it is very very important. Now when Na equal to J in two cases, either Na equal to minus Nb, it means for equimolar counter diffusion. Am I right? EMD, equimolar counter diffusion. Then N equal to J. Second, or when Xa is very small, Xa is very small. Xa क्या बच्चे? Mole fraction of species. It means when the solution is very dilute. When Xa is very very small, then what happened? This term can be neglected. Bolo. When Xa is very small, then Na plus Nb into Xa can be neglected. So even the equimolar counter diffusion is not there, but if the solution is dilute, for dilute solution, when the mole fraction of A is very very small, then the transfer of A because the bulk flow contribution is negligible. Am I right? And that is the case when partition is there and here large amount of A is very very small, only B is there. Now here the solid line that is A, now like that. Here only some molecules. Now in given volume means concentration of A is very very small, or we can say mole fraction of A is very very small, means solution is very dilute in A. When solution is very dilute in that species, when liquid solution is very dilute in that species, then in the flux of that species, in total rate of mass transfer of that species, the contribution of the bulk flow is neglected. Am I right? Bolo. Now because that term bulk flow contribution terms can be changed, its contribution is going to vary from one location to other location. Yes or no? Bolo. Its contribution, try to understand, sir. Its contribution, for example, suppose if 1 to 2 here, if this is the region of concentration difference here and here, from high to low concentration, CA1 to CA2, if A is diffusing from the one region of the high to low concentration, so at each and every point, what happened? The mole fraction of A is going to change, yes or no? Please tell me. At each and every point, at this point, at this point, at this point, at this point, at each and every point, the contribution of bulk flow term is changing. Why changing? Because concentration of A is changing. Because what is mole fraction of A? You know, XA is equal to CA upon CT. And if total concentration is constant, if the total concentration of solution is constant, then CA changing, then XA will changing, then the contribution is changing here, and dCA upon dZ is also changing. Now, sir, try to understand what I am saying. Actually, whatever I told you, कि bulk flow contribution, Mr. Karthik, it means at one point where dCA upon dZ is very high, yeah, it's very along with the location. Yes, excellent. Its contribution of bulk flow and molecular flux is going to change, and at the steady state rate of mass transfer, let's say flux is constant. If I am talking about the flux through constant area, then the flux is not going to vary with area, yes or no? Because if the mass is transferred, total rate of mass transfer is constant for a given total rate of mass transfer, both terms are going to change, yes or no? At location to location, both terms are going to vary from one point to other point, yes or no? In the flow field, in the diffusion path, this is diffusion path from 1 to 2. From this diffusion path, I will show you in the next example. From 1 to 2, as we are going to move from 1 to 2, at each and every location, the contribution of the both terms is going to vary, and that you can see, sir. dCA upon dZ is high at the one point, yes or no? Concentration gradient is very high, and it is going to be decreased as a drop here. Then the concentration gradient is very high, it means contribution of the diffusive flux is more in the total. Okay, so what I am saying you, कि total contribution of bulk flow and the contribution of diffusive flow is going to vary from point to point. Clear? That I want to discuss here. So this is only at particular position, at particular Z, but as Z is going to change, their contribution has to be changed accordingly. Contribution of both terms has to be changed accordingly. Clear hai? As XA will change, then the contribution is going to change accordingly. This has to be also changed to make the flux constant. Clear? But when the solution is very dilute, XA will be already very very small. Even the maximum value of XA is very very small. Even the maximum value of whatever possible value of XA is there, that is very small. We can neglect the contribution term, and only this is n equal to j. The two cases are there where n equal to j. Is this clear? Now, if you want to find out, for example, you can also think in this way. If you know the total flux Na at any given point, at any given z is found to be, let's say, 25 kilomole per meter square per second. If you know this, and you know the absolute velocity of A at that position Z, you know this is 2 meter per second, let's say, for example. You know the molar average velocity of a species at that position, because everything is going to change, na? Every terms is going to change, sir. मैं क्या बोलना चाहता हूँ, even the molar average velocity is what? CA into VA plus CB into VB upon CA plus CB total. Every terms is going to change from point to point, na? CA, CB, all are changing here, although CT is constant here. but CA and CB are changing. Velocity is changing. That's why V star also may be changed here. If V star is given to you at that point, V star is given to you, whatever value is there, they are given to you. And the concentration of A at that point is given to you, CA at Z is given to you. So can you calculate what is the contribution? How much percentage contribution of these terms are given? Na is given, V is absolute velocity is given, and V star is given to you. Now can you calculate, and CAZ is given to you, can you calculate how much contribution of bulk flow in the total flux? Please tell me. At that point, how much contribution? At that point, how much contribution of the bulk flow flux in total flux? Can you calculate? कितना contribution उस position पे, उस Z पे, where the data are given to you? Although this is always constant, but they are going to change. VA, V star, CA, they are changing continuously. So can you calculate how much contribution of the bulk flow is there? Yes, I can calculate, because I know J is equal to what? Now J equal to CA into VA minus V star. This is the contribution due to diffusive flux. CA is known to you at that point, VA is known to you, V star is known to you. You can go for this, and once you know this, you know that Na equal to J plus bulk flow contribution. You can go for Na minus J. You can go for the bulk flow contribution. Now percentage contribution is what? Na upon percentage contribution of bulk flow. Whatever you found here, Na minus J, it is contribution due to bulk flow upon total is Na into 100. That percentage contribution is there. It is clear. And that contribution is going to vary from point to point, because velocities are going to vary, concentrations are going to vary. Clear hai? That's it. I think you got the logic. If diffusion velocity is given to you at any given point of A, diffusion velocity of B is given to you, this is given, diffuse is given, CT is given to you, and CA is given to you. CA is given, CT is given, VA is given, VB is given. Now क्या क्या निकाल सकते हो इसे, जल्दी बताओ. At any given point in the flow field, they are given the VA, VB, CA, CT, DA, DB. Now find out the flux due to molar diffusion. Can you calculate? Yeah, I can calculate. J equal to what? CA into DA. I can go for J. I can go for the diffusive flux. I can go for Na as well. This is called as CA into VA. I can go for NB as well. CB into VB. How can you find the CV? Total concentration is constant. Then CT equal to CA plus CB. ये given है, CB निकालोगे. You can go for this. And once you know this, you can go for total flux, which is called as what? Na plus NB is equal to N. It is total flux. तो C ये आ गया N, and now N into, या तो इन दोनों जोड़ दो या तो माइनस कर दो, तो एवरीथिंग यू कैन कैलकुलेट. यस और नो? N into XA or N into CA upon CT, that is called as contribution due to bulk flow. बोलो है कि नहीं? For the A. So this is the point that you can solve. सिंपल क्वेश्चंस आएंगे, आप सॉल्व कर सकते हो. ठीक है, बोलो. अभी तो कोई डाउट नहीं है. नाउ प्लीज राइट डाउन स्पेशल, please write the case for equimolar counter diffusion, EMD. For equimolar counter diffusion, EMD, equimolar diffusion. For equimolar counter diffusion, Na is equal to minus of NB. There are various applications are there where moles of A and moles of B is going to flow in equal and opposite direction. Various applications are there. Example is that in the distillation column, I will show you. In the distillation column, Na equal to minus of NB. Moles of A and moles of B are moving in equal amount but in opposite direction when the total column is adiabatic and energy required to vaporize, molar latent heat of evaporation of A and B are equal. When the molar latent heat of evaporation of A and B both is equal, in that case Na equal to minus of NB. I will show you the application in the distillation column. But when Na equal to minus NB, then how can I apply the formula of this? Na is equal to, an example is, for example, suppose you have a two vessel and they are going to connect with the two bulb is there, two tank is there, and this consists of A plus B molecules, and here A plus B molecules are here, and they are connected with the pipe having length is L, and this is 1 point and this is 2 point. This is diffusion path. The length along which the mass is transferring, diffusion taking place, this is the length L. Am I right? Yes or no? The two tank you have, two container you have, and they are same temperature and same pressure. Same temperature, same pressure. It means concentration is same here. Total concentration is same. Ct equal to P by RT, and their gases molecules of A and B, gases molecules of A and B. Then this is the diffusion length through which the transferring is taking place. In this case, what happened? The Na and Nb are equal and opposite. Equimolar counter diffusion will take place. Here also A plus B, here also A plus B. And here concentration is given to, if concentration of A is more than, if Ca1 is more than Ca2 and Cb1 here, obviously because total concentration must be constant. तो अगर C1 ज़्यादा इधर, तो इधर क्या ज़्यादा होगा बच्चे? Cb2 is more than Cb1. Yes or no? Because total concentration must be constant. Then if you are connecting these two tanks having different concentration of A and B, then the diffusion will start. Bolo. Then in this case, the rate at which A is transferring from the left to right, same rate the B is transferring from the right to left. Then it is a case of equimolar counter diffusion. And when this takes place, so I am going to talk about molecular diffusion in gases or in stagnant medium. So either it is gas, it may be liquid mixture as well. It may be liquid mixture as well, where concentration of the both solutions are same. So what I am saying here, in the case of equimolar counter diffusion, how can find the flux of A? N equal to, you know, N equal to minus dAB into dCA upon dZ. Clear? Plus Na plus Nb into XA or YA, depending upon the gas or liquid. Now this will be 0 because N equal to J only. In the case of equimolar counter diffusion, N equal to only J. Am I right? Then my dear student, Na is equal to minus dAB into dCA upon dZ. Na at Z. Now, and if it is taking place through constant area, here diffusion is taking place through constant area, na? Area for the direction, area for the mass transfer is constant. Yes or no? If diffusion area is constant, if diffusion is taking place, write down. Just like in the heat transfer, if the heat transfer area is constant, if diffusion is taking place through constant area, then what happen? Please tell me. If diffusion is taking place through constant area, area for the diffusion is constant, then Na is not function of Z. Na Z is not function of Z. At all Z, flux will be constant, just like in the heat transfer I told you many times. Mr. Vishal, please wait for a moment. I will discuss, sir. Not for equimolar only, it is in the all cases. Mr. Vishal, please wait for a moment. And if Na is not function of Z, then simply you can integrate this as Na into dZ. This will be outside the dZ integration, minus dAB into dCA. You can integrate when Z equal to 0, or you can say Z1, this is Ca1, when Z2, this is Ca2. Then you can find the flux of A is equal to dAB into Ca1 minus Ca2 upon Z2 minus Z1. Okay, this may be valid for either gas or liquid, but for constant, through constant area. Equimolar counter diffusion. I think there should be no any problem. Bolo bhai. This you can write in terms of mole fraction, mass fraction, depending upon the gas or liquid. But generally this one. What is C1? C1 and C2 are the concentration at 1 point and 2 point. Now, what happens if equimolar counter diffusion is taking place but through varying area? Anyone? Here again two tanks are there having A plus B mixture. Here also A plus B mixture is there. This is diffusion length 1, and here it is taking place Z direction. what happened in this case? Now pipe is, previously there was circular pipe was there, now here it is decreasing area, and I am going to consider EMCD or EMD, equimolar counter diffusion. What happened in this case? What the change you will do? In this case, Na is a function of what? The only difference is that if here again Na equal to J, but J equal to minus dAB into dCA upon dZ, but this Na is a function of Z. Flux is going to vary. Na is a function of Z. Yes, rate of mass transfer is constant, but flux is not constant. So in this case, we should go for the rate of mass transfer. The rate of mass transfer is Na bar is equal to area into flux. Area Na at Z, area at Z into Na at Z. You know, whenever area is going to vary, always rate is constant. Means area into flux is constant. Yes or no? Bolo bachche. And Na bar is always constant. They are always constant. I have told you in the heat transfer as well. Recall kar lo. So area at Z into flux, I can write minus dAB into dCA upon dZ. Here rate is constant. I can write here Na bar into dZ without any problem. But this area is a function of the area is going to vary. This should be upon area as a function of Z. You should write here is equal to minus dAB into dCA. You can integrate and you can find the rate of mass transfer. बोलो कितने लोग याद है ये केस? थ्रू वेरिंग एरिया ज्योमेट्री. जैसा कंसंट्रेशन प्रोफाइल बनेगा वैसा ही टेम्परेचर प्रोफाइल बनेगा. ए का बी का अपोजिट. And when area is going to vary, then concentration profile क्या होगा बच्चे? Since rate is constant, you know rate is area into flux. Same concept is there. Since rate is constant, then area into flux is here. Then as area is decreasing, then flux should be area decreasing, then flux should be decreased, and flux means concentration gradient should be decreased. In order to have rate of mass transfer constant, as area decrease, then flux should be increased. Flux should be area decreases, flux increases, and flux increase means concentration gradient should be increased. Flux is maximum at which point? At 1 or 2? Flux कहाँ पे maximum होगा? Yeah. दिवाकर बताओ. Mr. Karthik. Now it's homework. You have to draw the concentration profile for the A and B as well. For the B, reverse case is there. A is diffusing in this direction and B is diffusing in this direction. You should draw the concentration profile as well as flux profile with Z. ये Z increasing हो रहा है इधर. ध्यान रखना. ठीक है? It's your homework. You have to draw the concentration and flux profile for the A and B as well. So what I told you, in this case a non-linear profile is there, na? But when the area is constant, then profile is linear. So in equimolar counter diffusion through constant area, in equimolar counter diffusion through constant area, the concentration profile is what? Bolo bhai. It is linear, just like in the heat transfer to slab. Equimolar counter diffusion through constant area. This you can see as Na is also constant, flux is also constant here, is equal to minus dAB into dCA upon dZ. It means dCA upon dZ is constant. Then dCA is equal to C into dZ. C1 मान लो. Then further integrate C is equal to C1Z plus C2. This C1 C2 can be found by the boundary conditions. At Z equal to 0 C1, at Z equal to C2 it is C2 CA2. Can you find yes or no? निकाल लोगे? तो same please draw Z axis here. CA1 CB1, here CA2 and here CB2. It is Na and here NB. C1 plus CB1 must be constant. CA2 plus CB2. that must be always constant. It means carrying out a constant temperature and pressure. तो सिंपल थिंग है, कोई भी इसमें आप हीट ट्रांसफर रिवाइज कर सकते हो सेम पैरेलली. नाउ द लास्ट थिंग I want to discuss here, the last thing that I want to discuss here for unimolecular diffusion, unimolecular diffusion, UMD, unimolecular diffusion, molecular diffusion. For unimolecular diffusion क्या होगा बच्चे बताओ? It is just like diffusion of A through non-diffusing B. It means diffusion of A through non-diffusing B. In this case the contribution of bulk flow will be there. क्यों ऐसा होगा मैं अभी दिखाता हूँ. Non-diffusing B, NB0, NB0 does not mean JB0, am I right? Here NB is 0, it means for an fixed observer, for him it seems that B is not diffusing, but actually what happened? Actually हो क्या रहा है? NB 0 है तो is this JB 0? No, the diffusion of B, it means contribution of diffusive flux of B is going to be exactly counterbalanced by the bulk flow. हाँ या तो उस केस में क्या होगा अगर हम अगेन then I can write general Na and Z is equal to J at Z. I am going to write in Z direction here. Then this should be what? Na plus Nb into Xa at any given Z. Nb is 0 here. Now जहाँ भी हमने Xa लिखा I can write in Ya. That's up to you. So I can write here Na. It is at any location 1 minus Xa. और बेटर इज दैट इफ आई एम गोइंग टू राइट वाई ए चलो ऐसे लिखते हैं कोई दिक्कत नहीं है. दिस इज इक्वल टू माइनस डी ए बी इंटू डी सी ए अपॉन डी जेड. सिंस ये एक्स है ये सी ए है आई शुड चेंज द सेम तो माइनस डी ए बी इंटू आई कैन राइट सी ए इक्वल टू व्हाट एक्स ए इंटू सी टी देन सी आई कैन राइट हेयर इंटू डी एक्स ए आई कैन राइट. एम आई राइट एनी प्रॉब्लम? दिस इज द जनरल इक्वेशन आई हैव रिटन. But now this equation I can only, this is valid for any case, either area is constant or area is not varying. So what is the basic difference? Flux of A is equal to minus dAB into C into dXA upon dZ upon 1 minus XA. This term will be there when the bulk flow contribution is there, am I right? And when XA equal to very very small, what happen? 1 minus Xa is nearly equal to 1, then N equal to J itself. I have told you, Mr. Karthik. This is valid for either constant area or varying area. But now, if I am going to apply for constant area, then Na is not function of Z. Then I can integrate and find the result. बोलो है कि नहीं? So when bulk flow contribution is there, then profile become non-linear. C क्या है? What is C here? Hanuman. What is C? What is C here? Total concentration. Yeah. Which is assumed to be constant. Very good. Now for constant area, for constant diffusion area, which area normal? This is the area should be normal to direction of mass transfer as in the heat transfer. So please, so Na is not function of Z, then Na into dZ you can integrate minus dAB into C into dXA upon 1 minus XA from Z1 Z2 XA1 to XA2. And whenever this is the condition, then Na into कुछ नहीं करना है, Z2 minus Z1 equal to minus dAB into C प्लस हो जाएगा ln 1 minus Xa2 upon 1 minus Xa1. Then तो कुछ भी हमारे ख्याल से याद नहीं करना है आपको. Na is found to be Na. This is the flux in the case of A is diffusing through non-diffusing, otherwise unimolecular diffusion. dAB into C upon Z2 minus Z1 into ln 1 minus xa2 upon 1 minus xa1. X1 xa2, anyone? It is the composition of A at 1 and 2 location. भाई 1 लोकेशन है, ये 2 लोकेशन है Z. तो 1 पॉइंट पे क्या कंपोजिशन है और 2 पॉइंट पे क्या कंपोजिशन है. कंपोजिशन आई कैन राइट इन टर्म्स ऑफ मोल फ्रैक्शन, मास फ्रैक्शन और मोल फ्रैक्शन और कंसंट्रेशन एज वेल. सिमरन क्लियर है? कुछ भी नया नहीं, सिंपल एक तरीके से. ये हो गया बच्चे Z1, ये हो गया Z2 2 पॉइंट पे. नाउ दिस यू कैन आल्सो राइट इन टर्म्स ऑफ यू नो XA1 plus XB1 means total mole fraction of a species at 1 point should be 1. Similarly, total mole fraction of all species at 2 points should be 1. So I can write here Na equal to dAB into C upon Z2 minus Z1 into ln XB2 upon XB1. And I can also write, since XBLM or 1 minus XALM, whatever you can say, 1 minus XALM क्या होगा बच्चे? 1 minus XA at 1 point, 1 minus XA at 2 point means 1 minus XA1, 1 minus XA2 upon ln 1 minus XA1 upon 1 minus XA2. This is same as XBLM. yes or नहीं? बताओ भाई 1 minus XA क्या हो जाएगा? XB, जल्दी बताओ. 1 minus XA क्या होगा सिमरन? XB होगा नहीं होगा? 1 minus XA क्या हो जाएगा? XB. तो XBLM भी आप लिख सकते हो, आपकी मर्जी है. इट इज कॉल्ड एज XB1 minus XB2 upon ln XB1 upon XB2. आपकी मर्जी है, कैसे भी लिखा जाता हो वैसे लिखो. You can replace this term with this. If you replace, you can find. आप इसको ऐसी फॉर्म में लिख सकते हो, आपकी मर्जी है. इससे भी आंसर तो सेम ही आएगा, बस हम फॉर्म चेंज कर रहे हैं. DAB into C just to compare with the both flux. It means when equimolar and unimolecular. इसलिए हम ऐसा कर रहे हैं. Z2 minus Z1 into XA XBLM. तो ये XB2 पर XB1 था तो रिवर्स हो जाएगा, है ना? माइनस प्लस इधर कर लो. ये XB2 अपन सिमरन, ये XB2 अपन XB1 है, ये XB1 अपन XB2 है, तो चेंज कर लोगे तो ये आ जाएगा आपके पास क्या? XB2 minus XB1 upon XBLM. और दिस इज कॉल्ड आल्सो X1 minus XA2. तो Na is equal to DAB into C upon Z2 minus Z1 into XA1 minus XA2 upon XBLM. Please see this. This is the flux of A in the unimolecular diffusion, or A is diffusion through non-diffusing B. Now the question is that where is the application of A is diffusion through non-diffusing B, and why in this case bulk flow contribution is there. I am going to clear this topic, then I will complete today's lecture. तो अब बोलो याद करना, याद नहीं करना है. कैसे याद नहीं करना है? देखो ये क्लियर है. नाउ कैन आई राइट द सेम इक्वेशन इन टर्म्स ऑफ कंसंट्रेशन? सिमरन, can you write the same terms in terms of concentration? Yes, I can write. How? This I have in terms of concentration. Driving force is concentration difference in XBLM. The similar equation I can write here. If I am going to multiply, the similar equation I can write in terms of concentration difference driving force DAB into CA1 minus CA2 upon Z2 minus Z1 upon CBLM. Am I right? चेक कर लो. C को अंदर भेज दिया, बट इसके लिए क्या हो जाएगा? XBLM क्या हो जाएगा? कुछ गलत है क्या? समथिंग इज रॉन्ग हियर. हाँ, XBLM को चेंज कर दो. देखो CBLM और XBLM में क्या है रिलेशनशिप, ये आप खुद निकाल सकते हो. CBLM मैंने क्या लिखा है? CB2 माइनस CB1 अपॉन ln CB2 अपॉन CB1. नाउ यू कैन राइट CB2 को इन टर्म्स ऑफ मोल फ्रैक्शन. व्हाट इज राइट? C इंटू XB2 माइनस XB1, है कि नहीं? C आएगा एक ऊपर. यस, दैट इज आई एम सेइंग हियर. तो ये जो आ जाएगा बच्चे, देखो DAB इंटू C इंटू CA1 माइनस CA2 अपॉन Z2 माइनस Z1 अपॉन CBLM। कुछ नहीं करना है, एक याद हो गया। तो यहाँ पे ड्राइविंग फोर्स क्या है, मोल फ्रैक्शन दो XBLM, ड्राइविंग फोर्स क्या है, कॉन्संट्रेशन डिफरेंस दो CBLM, और ये C यहाँ भी है, ये C यहाँ भी है। इज दिस क्लियर, यस और नो? दे आर सेम। तो फॉर दिस टू इक्वेशंस आई कैन राइट फॉर द लिक्विड फेज एज वेल एज, हाँ अगर गैस फेज होगा, दिस इक्वेशन आई कैन राइट एज अ फॉर गैस फेज, दिस इज फॉर लिक्विड फेज, आई कैन राइट द बोथ इक्वेशन। फॉर गैस फेज जहां x है वहां y हो जाएगा, DAB इंटू C अपॉन Z2 माइनस Z1 इंटू YA1 माइनस YA2 बोलो अपॉन YBLM। और ये तो एज इट इज रहेगा, क्योंकि कॉन्सेंट्रेशन आई कैन यूज द टर्म कॉन्सेंट्रेशन फॉर द गैस फेज एज द लिक्विड फेज। DAB इंटू C इंटू CA1 माइनस CA2 अपॉन Z2 माइनस Z1 अपॉन CBLM। एक और टर्म आ जाएगा इन टर्म्स ऑफ पार्शियल प्रेशर, ठीक है, इन द गैस फेज, बिकॉज पार्शियल प्रेशर टर्म इज ओनली गोइंग टू यूज फॉर द गैस फेज नॉट फॉर लिक्विड फेज। तो आई कैन राइट दिस एज अ DAB, क्या होगा बच्चे, इसको एज इज रहने दो C अपॉन Z2 माइनस Z1, जहां CO माइनस C2 यहां कर दो PO माइनस PA2, बोलो दिस शुड बी PA1 माइनस सॉरी अपॉन CBLM शुड बी रिप्लेस PBLM। आई थिंक दिस विल नो प्रॉब्लम, बोलो सबसे इजीएस्ट वे है। नाउ आई थिंक कुछ भी याद नहीं करना है आपको, एक फॉर्म को भी याद कर लो। दिस इज द केस फॉर एज डिफ्यूजिंग थ्रू नॉन डिफ्यूजिंग B। नाउ only thing is that in gas phase I can write the C as a P by RT, yes or no? बोलो, ये अलग चीज है। In gas phase I can write the C concentration as a total pressure upon RT, but not in the liquid phase, because liquid phase में there is no meaning for total pressure, है कि नहीं? बोलो। अब ये जो only जो difference क्या है बच्चे, for gas phase I can write C as a total pressure upon RT, and CA1 as a PA1 upon RT, partial pressure upon RT, you know very well, CA2 as a PA2 upon RT। तो जो फॉर्मूला आपने लिखा है थ्रू फॉर द एज डिफ्यूजिंग टू नॉन डिफ्यूजिंग B, दिस विल बी DAB, यू कैन चेक P upon RT, Z2 minus Z1, PA1 minus PA2 upon PBLM, यू कैन चेक, बिकॉज C को हमने P by RT रख दिया। बोलो, कुछ नहीं करना है, ये चीजें वे भूलने नहीं चाहिए सर, मैं रिलेट कर रहा हूं सारी चीजों को। फॉर लिक्विड फेज आई कैन राइट द C एज अ, जो टोटल कंसंट्रेशन है, दैट इज कॉल्ड एज average concentration of solution. Listen, this is called as average concentration of solution. And this is called as C1 plus C2 by 2, not CA1. Listen carefully, it is total concentration of solution at one point, total concentration of solution at second point. Very important. I am not written C1 C2, I write C1 C2. C1 C2 क्या है बच्चे? C1 क्या है? टोटल कंसंट्रेशन, इट इज मोलर और मास, मोलर कंसंट्रेशन। बोलो, तो लिसन केयरफुली, C1 प्लस C2 by 2, व्हाट इज C1? C1 क्या है? टोटल मोलर कंसंट्रेशन ऑफ सॉल्यूशन एट वन पॉइंट, टोटल मोलर कंसंट्रेशन ऑफ सॉल्यूशन एट सेकंड पॉइंट। In liquid case, the total concentration at 1 and 2 point can be changed. Mr. Sahil, you know, in liquid phase, what is X? Ca upon C. So what is C1? C1 I can write here, rho by m at 1 plus rho by m at 2 upon 2. Rho by m क्या है? What is rho? What is rho? Rho क्या बच्चे यहाँ पे? Rho is the mass density. Mass upon molecular weight become molar. ठीक है? Mass density of solution. And what is m here? Average molecular weight of solution at one point. तो अगर mass density दिया हुआ है and if you want to find out total concentration of solution, how can find out? You should divide by average molecular weight. है कि नहीं? If mass density of mixture you don't do, and if you want to calculate the molar density of solution, then what you should do, you should divide by average molecular weight. So this is the way how you can find out the, if density is given to you. So for example, if you have a two liquid solution here, there are two liquid solution of A plus B, and their density are given to you rho 1, their density is given to you rho 2. Rho 1 and rho 2 are the density of solution at 1 and 2 point. Their mass density. If they are molar density, then what you should do? Then simply C1 plus C2 are the molar density itself. है कि नहीं बताओ? अगर ये मास नहीं मोलर दिया हुआ है तो क्या है? C1 ही तो दिया हुआ है भाई. C1 क्या है? मोल पर मीटर क्यूब है कि नहीं बताइए भाई? If rho 1 and rho 2 are the molar density, then it is exactly C1. But if it is mass density, then you should find out the M1. How can you find the M1 बच्चे? M1 कैसे आएगा? This is the average molecular weight. This is called as summation of M A into XA. समझ रहा है नहीं? MA into XA 1 plus MB into XB1 1 point पे. Similarly, M2 average molecular weight of 2 here. Then it is what? MA into XA2 plus MB into XB2. molecular weight तो चेंज होगा नहीं. समझ गया? तो इट्स सिंपल कैलकुलेशन. माय डियर स्टूडेंट, एक चीज़ और मैं आपको बताना चाहता हूँ. बहुत सारी चीज़ें बताने के लिए मैं, बट जो अभी जो इम्पोर्टेंट हमें याद आ रहा है मैं आपको क्लियर करता जा रहा हूँ. सुनो, अगर मैंने कोई भी फॉर्मूला लिखा, सपोज Na, हाँ, दिस इज कॉल्ड एज मोलर फ्लक्स, मीन्स किलो मोल पर मीटर स्क्वायर पर सेकेंड. दिस इज फाउंड टू बी DAB इंटू C अपॉन Z2 माइनस Z1 into XA1 minus XA2 upon XBLM. Here two types of flux I can write here. One is Na in kilomole, other I can write here mass flux. It is molar flux, I can also write mass flux. Yes or no? So when we have to go for the mole, when we have to go for the mass flux, बोलो भाई. इसको हम लिख सकते हैं किसमें? लेट्स से आई एम गोइंग टू डिफाइन Na प्राइम. प्राइम छोड़ दो, हाँ प्राइम मान लो, चलो. लेट्स से WA इज कॉल्ड एज, या MA मान लेते हैं मास फ्लक्स. चलो MA kg पर मीटर स्क्वायर पर सेकेंड मास फ्लक्स. व्हाट चेंज विल फाउंड हियर? आई एम गोइंग टू टेक द सेम फार्मूला DAB C Z2 minus Z1 XA1 minus XA2 upon XBLM. What the change is there? Anyone? बताओ भाई, इन दोनों में क्या डिफरेंस है? एक मास फ्लक्स है, एक मोलर फ्लक्स है. फॉर द एज डिफ्यूजिंग टू नॉन डिफ्यूजिंग B, what is difference? In this formula, whatever X1 X2 are there, they are mole fraction. Am I right? Everything in terms of mole. X1 X2 are the mole fraction and C is the molar concentration. Listen, very simple is that C is the molar concentration, X1 is the mole fraction at 1 and 2 point. Then we got the answer in kilomole. और यहाँ पे जो X1 X2 है, that is what? Here the X1 X2 are the mass fraction and C is the mass concentration. C is the mass concentration. Are you getting my point? Now, this is the mass concentration that you should know. It is mass concentration. Mass. What is mass concentration? Mass density. Mass concentration or called as mass density. Mass density of mixture. Mass concentration. And how can find the mass if it is gas phase? अब देखो, अगर gas phase है, how can find the mass concentration? Anyone? If pressure and temperature is given to you, for a gas phase, if the pressure and temperature is given to you, then how can find this C? And how can find this C? That is difference I want to show you. This C I can write as a P upon RT directly because they are molar concentration. And this is mole or kilomole per meter cube, that you don't know. That you know. Yes, this should be simple. Here the C equal to PM by RT. Total pressure, temperature, and what molecular weight I am talking about? Average molecular weight. Yes. But एम एवरेज तो चेंज होगा हर जगह, एवरेज मॉलिक्यूलर वेट तो चेंज होगा ना बच्चे, बोलो भाई। तो बेटर क्या है, इसी को मल्टीप्लाई कर लो। देखो जो बेसिक जो इक्वेशन है दैट यू विल फाउंड इन टर्म्स ऑफ कंसंट्रेशन, सबसे इजी फॉर्म जो है, if you have any problem with this then what you should write here. In this case no problem in the case of molar. मैं क्यों बता रहा हूँ, because sometimes if the composition are given in the case of mass fraction then you should go for the mass, if they are given in the mole then you should go for the mole, that is easier for you. Ranjan Singh, R bar of what, समझे नहीं? They will simply give you, in this case they will give you total concentration and that is constant, then C into x1 mass fraction is given to you, the mass fraction is there, then what you should do here, their mass fraction, then x7 into c1, this is called as, they will give you, in this case total concentration is always given to you, that is constant. Rananja, not for here single gas is not there na, here it is single gas, no, it is mixture of gas A and B. Mr. Rananja, try to understand, you should think in this way, otherwise you can say C is always constant, then what happen, always the average molecular weight values will be constant, summation of average molecular weight will always be constant. This is in the way, because in the gas phase if you are going to carry a constant pressure and temperature, then obviously the M average will always found to be constant at any given point. Is this clear? Simple, common sense, because C is always constant. But at a given pressure and temperature, what I am talking you, at a given pressure and temperature, molar concentration is constant and mass concentration is constant. That is very important. So to avoid this problem, what you should do, listen, to avoid this problem simply you should multiply, because total concentration is given to you in this problem, multiply with this x7 and avoid the problem, that's it. Clear है, बोलो भाई। तो उस केस में मास कंसंट्रेशन जो है सोल्यूशन का that will given to you, otherwise simply they will give mass concentration, तो इसको मल्टीप्लाई करके क्या जाएगा C1 and CA2 and they will simply give you C1 and CA2 2 points, बस बात खत्म, इसकी जरूरत ही नहीं पड़ेगी। सिंपल CA1 they concentration, the mass concentration is given to you at the 1 and 2 point, mass concentration of A and B, ठीक है। तो ये सिंपल लॉजिक है, वो आप देख सकते हो, कोई बड़ी इशू नहीं है। Now if you compare, तो आई एम गोइंग टू राइट जनरल, तो ध्यान रखना मेथड क्या, शॉर्टकट क्या है, शॉर्ट नोट्स टाइप में कुछ क्या है, फॉर UMD और EMCD equimolar counter diffusion, the formula is Na, I can write as Na equal to J, first of all you know very well, bulk flow term is 0, and when Na equal to J, this is found to be DAB into CA1 minus CA2 upon Z2 minus Z1, okay, in terms of when driving force is concentration difference. It is also equal to what, I can write in terms of DAB into in partial pressure, I can write as a in terms of mole fraction, this is C into XA1 minus XA2 upon Z2 minus Z1, also equal to DAB into C into for gas phase Y1 minus Y2, बस ये चेंज होगा, into C, and one more form you should write here only, this C, this gas प्रेशर के फॉर्म में, DAB C हो जाएगा क्या, C इंटू Y1 क्या हो जाएगा, C P1 अपॉन RT, PA1 माइनस PA2 अपॉन RT Z2 माइनस Z1, ये हो गया बच्चों, बताओ मेरे ख्याल से दे ऑल आर द मोलर फ्लक्सेस C1 P1 हर साहब, एनी प्रॉब्लम, दिस फॉर EMCD, फॉर यूनिमोलकुलर डिफ्यूजन, एज डिफ्यूजन टू नॉन डिफ्यूजन की करस्पॉन्डिंग इक्वेशन क्या होगा, जल्दी बताओ, व्हाट इज करस्पॉन्डिंग इक्वेशन फॉर दिस, फॉर इक्विमोलर काउंटर डिफ्यूजन क्या होगा, कुछ भी याद नहीं करना, आज ही जो पढ़ना यही पढ़ो यही रिवाइज करो, करस्पॉन्डिंग इक्वेशन फॉर द यूएमडी याद करो, जल्दी बताओ। ऑलवेज इन द प्रेशर डी ए बी इंटू पी आ जाएगा, यहाँ पे आर टी आ जाएगा पी ए वन माइनस पी ए टू अपॉन पी बी एल एम। करस्पॉन्डिंग इक्वेशन फॉर दिस डी ए बी इंटू सी ए वन माइनस सी ए टू इंटू जेड टू माइनस जेड वन इंटू सी बी एल एम। करस्पॉन्डिंग इक्वेशन डी ए बी इंटू सी अपॉन जेड टू माइनस जेड वन इंटू एक्स ए वन माइनस एक्स ए टू अपॉन एक्स बी एल एम। And corresponding equation is, I am going to write here, Na equal to dAb into C into ya1 minus ya2 upon z2 minus z1 into ybLm। या तो जो सिंपल जो कॉन्सेप्ट क्या है, या वेरी गुड। तो आप पूरे को रिजल्ट को खुद आप देखो। जस्ट मिस्टर कार्तिक, इफ यू ऑब्जर्व व्हाट यू फाउंड, आई थिंक यू कैन राइट दिस योर ओन। इफ यू फाउंड Na for the case of UMD, unimolecular diffusion, upon Na for EMD, this is found to be ratio of these two fluxes is going to find P upon PBLM। तो मैं कहता हूँ आप EMD निकाल लो, उसमें ये मल्टीप्लाई कर दो, बात खत्म। This is also equal to C upon CBLM। Also equal to 1 upon YBLM, 1 upon XBLM। They must be dimensionless, तो यहाँ पे 1 होगा क्योंकि इसका ऑलरेडी डायमेंशनलेस है। ये तो इवन अगर आपको फॉर्मूला याद नहीं आ रहा है तो ये तो पता होगा ना, ये रेशियो P अपॉन PBLM, C अपॉन CBLM, 1 अपॉन YBLM, 1 अपॉन XBLM। तो बच्चे यू शुड गो फॉर इक्विमोलर काउंटर डिफ्यूजन एंड देन मल्टीप्लाई विद corresponding terms to find out the UMD। For dilute solution, you will found that their ratio are equal to 1। For dilute solution, P upon PBLM, C upon CBLM, 1 upon YBLM and 1 upon XBLM, they are approximately equal to 1.0। They are close to 1 for dilute solution, because I told you for dilute solution both are equal। They are flux, if you want to find the rate you should multiply with the area, like नहीं? And the last thing, please give me 5 minutes, give me 5 minutes here। Now I have told you binary mixture, right? Heading is binary mixtures, this is the last topic, it will take hardly 5 minutes। Binary mixture, it means only mixture of A and B is there। Then I told you कि for binary mixture I can write Na equal to J plus Na plus Nb into Xa or Ya, and Nb is found to be Jb plus, चलो लिख लिया तो ठीक है। If you are going to add these two equations, equation 1 it is flux of A and flux of B। If you are going to add these two equations, Na plus Nb, what will found? J plus Jb plus Na plus Nb, Xa plus Xb equal to 1, this is cancel out, then J plus Jb equal to 0। Am I right? Yes or no? So in any of the cases always J plus Jb equal to 0, but this is not only for binary mixture, this result is not only for binary mixture, for multi-component mixture also। If we have more than one mixture, फिर भी क्या होगा बोलो? If you have more than one mixture, then always Xa plus Xb plus Xc plus Xd equal to 1, then it is cancel out, then always J plus Jb plus Jc plus Jd is always equal to 0, है कि नहीं? बताओ। Not for binary mixture। देखो this is summation of Ji is always 0 for I equal to 1 to n, for n number of species, तो either केस इक्विमोलर काउंटर डिफ्यूजन और चाहे इक्विमोलर हो, either नॉन इक्विमोलर, either इक्विमोलर, नॉन इक्विमोलर, इक्विमोलर और यूनिमोलिकुलर, in any cases always summation of ji equal to 0. Yes or no? Always summation of ji equal to ja plus jb always 0, but ja and jb individually can never be 0. Are you getting a point? Then why I have written for binary mixture? So this result is not only for binary mixture, this is valid for any of the number of species I can write. But I want to show you when j and j for binary mixture, j I can write as minus of jb. Yes or no? For binary mixture. And if this is the case, then j equal to what? Minus dab into dca upon dz, and this is equal to minus dba, b for b, diffusion of b in a into dcb upon dz. It is cancelled out since total ca plus cb, and since total concentration is always constant, total molar concentration is constant or mass concentration constant. Please tell me. Yes, molar concentration is constant, not mass concentration. Molar concentration and mass concentration both are only going to be constant when the molecular weight of every species are equal, otherwise not. So ca plus cb here, and I am talking about here. So what is cb? C minus ca. If we differentiate, then dcb equal to, it is 0 minus of dca. Now please put here, and if you will put here, what you got? dab is equal to dba. कि binary diffusivity in a to b equal to b to a. Bolo, is this correct? So this is diffusivity of a and b equal to b into a, b in a, that is only for binary mixture. Now this result is valid for, so two result is very very important. This is for binary mixture only, but summation of ji is always 0 for all cases, either binary or tertiary or quadruple, कितने mixture हो, all, and for all types of mass transfer operations, चाहे liquid में चाहे gas में, दोनों में ये valid होगा. बस binary liquid mixture होना चाहिए, binary gas mixture होना चाहिए. ठीक है? Now second thing is that, for example, for UMD, unimolecular diffusion, बताओ, for unimolecular diffusion of A, for unimolecular diffusion of A in binary mixture, क्या होगा बच्चे? Is Na 0 or non-zero? For unimolecular diffusion of A, is it possible to have Na equal to 0? Unimolecular diffusion of A through non-diffusing B. Unimolecular diffusion of A through non-diffusing B, is it possible to have Na equal to 0? अंशिका, Na 0 हो सकता है चूंकि डिफ्यूजन A का ही हो रहा है through non-diffusing B. Na can never be 0, but Nb will be 0 here. Clear? What about J and Jb? Is they are 0 or non-zero? What about J plus Jb? This is always 0. But what about J and Jb respectively? They are 0 or non-zero? They are non-zero. Bolo, how many of you are satisfying with this? For EMD, for equimolar counter diffusion, क्या होगा? Na is not 0, Nb are not 0, but they are even equal in magnitude. ये भी सही है, ये भी सही है, ये भी सही है. And J plus Jb is 0, ये तो हमेशा ही होगा. J is not equal to 0, Jb is not equal to 0. बोलो, clear? Vishal, yes, here Na plus Nb is 0 and J plus Jb is also 0. ऐसा बोल सकते हो? Yes, ये भी correct है. Clear? Now last point एक खत्म करता हूँ तो ये टॉपिक पूरा खत्म हो जाएगा. टॉपिक क्या है कि अब what is going to happen in the age diffusion to non-diffusing B? What is reason for bulk contribution? Just listen here. If suppose this is the liquid, is going to, it is here A and that is B. A is diffusing into the B. This is the diffusion length. It is called as Z1 और ये है Z2. A को डिफ्यूज होना है कहाँ से बच्चे? Z1 से Z2 में. समझ गया? बोलो. हमें भूख लग रही है भाई. बस लास्ट टॉपिक खत्म कर दो, टॉपिक खत्म, अदरवाइज कल फिर उसको स्टार्ट करने में टाइम लग जाएगा. 2 मिनट वेट कर लो प्लीज. A has to be diffused from the A liquid है. This is the liquid A and this has to be diffused in the gas air. Air is going to be above the tube. B stagnant का मतलब क्या है? समझो बात को. What is meaning of stagnant B? What is meaning of saying B stagnant? What is meaning of saying B stagnant, sir? Meaning of saying B stagnant is that at each and every point, this is the diffusion length. It is Z1. This is the direction of diffusion. यहाँ से यहाँ में diffusion होगा. And diffusion का area क्या है? Constant है कि नहीं है? Diffusion area is constant. बोलो. Diffusion area is constant. भाई B is नॉन डिफ्यूजन का मतलब क्या है कि एक्चुअली B is what condition makes the B non diffusing. इसका मतलब ये नहीं B रुका हुआ है. समझो बात को पहले एक बार, ये मैं क्लियर करना चाहता हूँ. ये डिफ्यूजन पाथ है. थ्रू डिफ्यूजन पाथ एरिया फॉर द मास ट्रांसफर इज कांस्टेंट एंड ये डायरेक्शन है जिधर मास का ट्रांसफर हो रहा है. क्लियर? समझो. व्हाट इज द मीनिंग ऑफ सेइंग B इज नॉन डिफ्यूजिंग? कि B रुका हुआ है? नहीं सर. एट ईच एंड एवरी पॉइंट, at this point, at this point, at this point, at this point, at this point. If means if I'm going to draw the profile Z here, 0 to L. L is the length of the. Through each and every point, what happened? The NB must be 0. इसका मतलब क्या है? सर समझ लो, कहीं नहीं मिलेगा. Means actually B is the air. Let's say air is insoluble in the liquid. No. सर कंसंट्रेशन अगर सेम हो जाएगा मैम तो फिर तो दिक्कत हो जाएगी. Ansika ma'am, listen carefully. Ma'am, I've told you NB 0. What it means? It means just go for definition. NB equal to JB plus NA plus NB into XB. It means if it is 0, it means whatever the flux of B because of molecular diffusion is going to be counterbalanced by the bulk flow of B. Are you getting my point? B is moving. Fish is actually moving. B is the fish. Fish is actually moving. But for an observer, what happened? Since B is moving, but equal and opposite counter will balance here. That's why it seems for an observer it is stationary. It means at each and every point for an observer in diffusion path, it should be 0 throughout the point. हर एक point पे NB 0 होना चाहिए सर. and NB 0 होने के लिए क्या होना पड़ेगा? JB तो vary करा ना. If JB is going to vary, then accordingly this term should be also vary. This is bulk flow. I have told you कि bulk flow term is not constant throughout the point. ना bulk flow is going to vary with the composition. With point to point bulk flow is going to vary. मानते हो या नहीं मानते? बताओ. समझो. मैंने बोला bulk flow contribution. The contribution of the bulk flow in total flux is going to vary from point to point. और ये इस तरीके से this is going to both terms are going to vary in such a way कि NB will become 0. At each and every point they are equal and opposite. At each and every point they are equal and opposite, but they are differently equal and opposite. Their values are different. Yes. हर एक पॉइंट पे उसको कैंसिल करना है. Then NB is 0 सर. इतना आसान नहीं है कि बस से उसके लिए स्टैग्नेंट है, अरे 0 कर दो NB. बट उसके पीछे लॉजिक तो समझो सर. Now it means here, listen. What happened? What makes the bulk flow in this case? Air is insoluble in the water. So as the air will get diffuses, as this will get diffused here, then this has to be diffused here. It is J and this is JB. Am I right? It is J and there JB. And you know J plus JB is always 0. Yes or no? The rate of increase in the concentration of A is equal to rate of decrease in the concentration of B. Am I right? dCA upon dZ is exactly equal to minus dCB upon dZ. कौन कौन जस्टिफाई करता है इस बात से? सर लॉजिकली समझो सर कि I told you J plus JB is always 0. It means the rate at which the concentration of A is going to decreases, the same rate the concentration of B is going to increases. Now if I'm talking about this as Z direction, so as you are going to move in the positive Z, so concentration of A get decreases. So rate concentration gradient concentration gradient at each and every point, rate of decrease of concentration at each and every point is equal to rate of increase of concentration of B minus dCA upon dz equal to always plus dCB upon dz, if this is the plus z direction, because J plus JB is always 0, and because binary diffusion is there, then what happen, DAB and DB are same, they are equal. बोलो, तो concentration profile for the A is going to be decreases continuously minus dCA upon dz. Rate of decrease of the concentration at every point is going to be equal, they are equal in magnitude, but opposite in direction. जस्टिफाई करते हो या नहीं करते हो, बिकॉज जे प्लस जे बी 0 और जे प्लस जे बी 0 डी ए बी डी बी सेम है, तो फिर तो वही आ गया ना. बोलो, मानते हो? तो सर दिस इज जे एंड दिस इज जे बी. नाउ at the same time what happen, as the B is going to enter, as B is going to come at this point, what happen, since B is insoluble, since B is insoluble in the, this A is going to carry in the B, this A will carry in the B, but this B will not going to accept by the A. Yes or no? It means you can say A has a source and sink. For A, source is there and sink is there, but for the B only source is there, sink is not there. वो कहाँ जाएगा, निकल तो दिया, घर से बाहर निकल दे, कहाँ जाएगा वो, because this is not going to accept. Are you getting point? For A there is source as well as sink, but for B there is only source, no sink is there. Sink means there is nothing to absorb, nothing to accept is there, accept. And since there is nothing to accept, what happened, it start accumulate. But the process steady state, what should happen? To make the process steady state, what happen? Equal and opposite amount has to be, equal and opposite amount has to be. बोलो, अब यहाँ पे देखो, here J is there and bulk flow is also there, Na. For A, Na is also there, and here Nb is in opposite direction of the JB. So now two bulk flow is there, Na and Nb. It is better to write bulk flow. No, it is better to understand in this way. If this is here, for A, this is called as diffusive flux. Diffusive flux for A, and sorry, for A there is bulk flow term, bulk flow of A and diffusive flow of A, both in the same direction. Yes or no? Diffusive flow of A, both in the same direction. It is for A, bulk flow of A and diffusive flow of A. As for the B, no, diffusive flow of B is in this direction. This is called as diffusive flow. Diffusive flow of B and the bulk flow of B in this direction. Bulk flow of B, and they every point that should be make 0. Total is what? This plus this. Here this plus this. So in this case, here the bulk flow will support this total rate of mass transfer, and here it will decrease, and this makes 0. Clear hai? The direction of bulk flow of B and diffusive flow of B. Here diffusive flow of A and bulk flow of A in the same direction. Okay? Bulk flow, diffusive flow, bulk flow, diffusive flow, B and A. तो concentration profile for the B क्या होगा बच्चे? यहाँ पे if this is the Z here, as we are going to move here, the B is maximum. As we are going to move, concentration B is going to be decreases. So what profile is there? Logarithmic profile is there. You have seen how the profile we obtain, that we will discuss in the next lecture. Okay. So we have seen in the case of equimolar, profile is linear, but in the case of A is diffusing to non diffusing B, तो हर एक पॉइंट पे NB 0 होना चाहिए इन डिफ्यूजन पाथ. समझ गया ना? एट ईच एंड एवरी पॉइंट द NB मस्ट बी 0. तो जब कंसंट्रेशन चेंज होगा तो बल्क फ्लो कंट्रीब्यूशन भी क्या होगा, चेंज होगा. तो प्रोफाइल अबाउट द एज डिफ्यूजिंग नॉन डिफ्यूजिंग भी आई विल डिस्कस बाय टुमारो. तो मेरे ख्याल से कुछ समझ में आया होगा, कुछ कॉन्सेप्ट क्लियर हो गया Na और J में, और जो कन्वेक्टिव एंड ऑल थिंग्स, बल्क फ्लो कंट्रीब्यूशन क्या है, कौन सा बल्क फ्लो की हम बात कर रहे हैं, शायद आपको विजुलाइज हो गया होगा. ठीक है.